Hey, what's going on, everybody? How are you doing? Hope you guys are doing well. Happy Sunday from me to you, or happy Monday, wherever you may be. We are in it to win it tonight, chat. Hopefully, fingers crossed, we are L-1 hour and 49 minutes from launch, just shy of 2 hours. I'm hoping we can get the New Glenn Maiden flight launched and under our belt here in 2025. That would be nice. That'd be nice. New Glenn has postponed, scrubbed is not the right word, postponed several times already. Not to mention that, you know, technically speaking, by old school Blue Origin's timeline, they were expecting to launch back in like 2019 or something like that. But here we are in 2025. New Glenn is a beast. It is such a good looking rocket. So yeah, like I said, we are just under 2 hours to launch. We're just shy of about 45 minutes until the actual live stream should start by Blue Origin. And also here in the background we have NSF bringing the current views that you're seeing. They are at the Cape, as they always are, with many a different camera view. They also have some B-roll footage from some Jeff Bezos, Jeff Who, bringing them around the factory. So that right there is the massive layup machine that they use to create New Glenn's fairings. New Glenn's fairings are huge, absolutely massive. You can fit 20 moving trucks inside of it. It is massive, chat. It is ginormica. So yeah, that's, you know, they haven't started yet, but I'm pretty sure we've seen in the past Blue Origin working on fairing reuse. I don't believe that's in their timeline for this launch or the next one at all, but we have seen them start doing some testing around the Cape Canaveral Space Force Base turnaround basin near the actual port. They actually put a massive fairing test article in the water and fished it out with a crane, made sure it floated, and you know, trying to make sure how they could actually operate fairing reuse. So hopefully we get that in the future as well. By the way, what's up, Andy? How are you doing? Tears, good to see you. And Frizz, what's good? Hey, if they pull this off, I have nothing against it. Hell yeah, exactly. My point exactly. So we talked about this in Discord a little bit. What is the probability of success for a landing on the very first go? I kind of attribute this in some way, shape, or form with a few obvious caveats, similar to what SpaceX was able to do on their first catch tower attempt with Booster. Now, granted, they also did some soft water landing tests with Booster before the catch tower, but let's not forget that Blue Origin does have at least some experience with precision landing of rocket vehicles. So even though it's subscale with New Shepard and it's not an orbital class rocket, that stuff, that technology, that knowledge does carry over. It's a tall order though. It's a tall order to go from subscale, suborbital vehicle that basically just goes straight up and comes straight back down, landing on the pad, to then having an orbital class rocket go, you know, 600 kilometers downrange and then land on a moving target. Moving as in waves and things like that onto the Jacqueline vehicle. And this is one of the graphics that I had queued up as well. This is where I got that number. 20 moving trucks can fit inside of that fairing. Absolutely enormous. It's a 7-meter wide fairing. For those of us that don't use the metric system, it's 23 feet wide, or essentially 2 stories tall. I'm sorry, it's 2 stories tall wide, right? 7 meters is like 23 feet. So this dimension right here, it's 2 stories. It's huge. It's such a massive launch vehicle. If you guys remember back in like 2014 or something like that, when New Glenn was just the twinkle in the eye of Blue Origin. Yeah, I was about to say somebody else. The twinkle in the eye, they were calling it the Bigger Brother. Yeah, the Bigger Brother launch vehicle, or the Bigger Brother project, if you will. And then that came to be New Glenn. and it is definitely, in comparison to New Shepard, absolutely huge. By the way, New Shepard can fit inside of this fairing comfortably. It can fit inside this fairing. So yeah, it's, oh man, the size cannot be understated, chat. Is it the largest fairing ever? Starship doesn't count. How big was, well, no, yeah, technically. I think it is actually. I was trying to think how big is the Vulcan, but Vulcan's only 5 meters, so I think it is the largest currently. That's actually a good question. It might be the largest. Yeah. Unless there's something weird like there was, you know, the cargo variant of Saturn V fairing or something like that. But yeah, this might be the biggest one, which is pretty crazy to think about. Yeah. You're hyped. I'm hyped. It's going to be good. Well, we could feel proud if you've ever bought stuff via Amazon. You've paid for it tonight. Yeah. It's crazy what you can do with like several $100 million budget a year. For Blue Origin, which I honestly say I don't obviously know the exact number, but I want to say their working budget is like $500 million a year, and it goes into this. They spent over $200 million just developing Launch Complex 36, and they had to do 2 integrations on Launch Complex 36 because they have both A and B. They basically turned the double launch complex that was there, A and B, into a single large launch complex with testing capabilities. So yeah, they completely overhauled Launch Complex 36. They have the massive new integration facilities, both at Launch Complex 36 that we see right here, but they also have the huge, massive New Glenn assembly building also at the Cape, which is just, that right there is also one massive mega facility. And then they built, I believe, 2 assembly lines in Huntsville, Alabama for BE-4 rocket engines. New Glenn, of course, uses 7 BE-4 rocket engines on its first stage, and then Vulcan also uses 2 BE-4 rocket engines. And so they developed a massive assembly line in Huntsville for both of those capabilities. So yeah, that and all of this in the last decade, by the way. Blue Origin has been operating pretty quickly, actually. Vertical or horizontal assembly? Great that you asked. So it should be horizontal. Everything is horizontal. Let's go to the rocket notes here. I have some great pictures queued up. There it is. Yes, it is a horizontal integration facility, as well as an assembly building as well. So this is, I believe, in the integration facility. And then they actually have a massive building where they manufacture their first and second stages as well. But yeah, so this is a picture of the New Glenn integration facility. This is where they actually integrated. You can actually see the test article fairing that they had here. It was basically just a dummy system that they placed on top of the second stage during fitness checks and things. And then when they encapsulated their payload, which it does have a payload tonight, which is pretty awesome, called the Dark Sky 1, also known as the Blue Ring. Dark Sky 1 is basically the prototype of what will become Blue Ring. Blue Ring is supposed to be an orbital transfer vehicle, or OTV. Basically a vehicle that can host a whole bunch of payloads on it and move it into different orbits, like a propulsion module or something, if you want to call it like that. But yeah, so that is what we have there. But it is absolutely massive. This is the second stage, by the way, chat, this picture here, just to kind of get a sense of scale. This is the second stage with 2 BE-3U upper stage engines. The BE-3U is, of course, directly developed off of the BE-PM. No, I'm sorry, the BE-3PM. My God, all the letters with Blue Origin. The BE-3PM, or propulsion module, is what actually powers the tail for the New Shepard. So they took the New Shepard design, which is a tap-off cycle, and they created I believe it's a split expander cycle. Which is actually pretty crazy. We can go into all of that here at some point in the stream. But there's another picture of the second stage. Notice, by the way here, chat, notice the humans for scale. That's a human for scale. In the foreground, might I add, right? They're not back here. This is a human for scale. They don't even look to like come up to the bottom of the transporter system. And then it also looks like potentially they could fit inside the engine bells of the BE3U expansion nozzle. Like I said, absolutely massive. Again, this vehicle wide, so this vehicle is as wide as a 2-story building is tall. So like this would be a 2-story house right here that New Glenn's upper stage could actually fit. It's actually crazy how big this system is. But yeah, so here we see a picture of them working on moving the vehicle out of the integration facility to do pad fit checks. This was, I believe, back in September or October. But yeah, so this is the fully integrated first stage, and then you can also see just how big this massive system is. They have 2 SPMT style of vehicles. There's a human for scale in the background. There's a human for scale in the foreground. There's a Ford F-250 in the foreground as well. I don't know if that's an F-250. It's only single axle in the back, but yeah, absolutely massive vehicle. Oh, there's a perfect picture to show you scale, chat. There is a perfect picture. So it's bigger than the entire interchange for an American 3-lane highway system. It's crazy, chat. This thing is absolutely enormous. I didn't even know New Glenn was about to launch. Well, there you go. Space Flight Fusion, welcome, welcome, welcome. We anxiously await. Yes, indeed. Can't see the banana, it's too small. Yeah, basically. Yeah, so this vehicle, absolutely huge. So talking about, of course, the actual mission tonight, chat. The mission is to test the Blue Ring Pathfinder. This vehicle does have a payload. The Blue Ring Pathfinder, also known as Dark Sky 1. I'll show you a picture here in a little bit. The highway intersections down there are intentionally made larger to fit rockets. Yeah, 100%. The booster's name is So You're Telling Me There's a Chance, inspired by the Dumb and Dumber movie quote. That's something that we can definitely get into. They say, you know, recently, and I mean like recently, it seems like Blue Origin's been pushing that whole like, oh, you know, we'll be happy if it fails, we'll be happy if it works, you know, we're just testing, we don't even know if it's going to get into orbit. That works for SpaceX. To me, that doesn't exactly work for Blue Origin because they have a completely different way that they operate. SpaceX is very much like helter skelter, let's just fly things and break things and learn and figure out how to improve things. Blue Origin is very much a more, I guess you could say, old school mentality, similar to like NASA, but also kind of like a new NASA. They definitely do things pretty quickly. I mean, they developed the entire New Glenn rocket that's about to fly here in less than 10 years, which is pretty crazy. So that's awesome. And it's also going to be the I guess largest operational vehicle if they can get into the operational regime before SpaceX can with Starship. Like, it's absolutely huge, this vehicle, right? 45 metric tons into low Earth orbit by itself, which is, yeah, like I said, the scale cannot be understated. But they very much have that same sort of mentality where they do a lot of subscale testing before they get to what's known as a proto-flight vehicle. Proto-flight basically means your prototype is also your flight qualification system, which is exactly what NASA did with Artemis 1. You did a whole bunch of testing, right, to develop one rocket. You launched that rocket and it should work. So to me, the whole like, so you're telling me there's a chance, and the mentality of we'll be happy with whatever happens, I don't think quite works for them. There's definitely still some things to be said about that. Like, obviously, no matter what happens, they're going to get flight data and all of that sort of stuff. But I expect them to do more than this, you know, we'll see what happens sort of mentality. Like, they should be, I would be surprised if they don't make orbit. I would seriously be surprised. So knock on wood on that front, right? What do you think the size limit on horizontal integration is? When will they not be able to use a strong back to lift the rocket to vertical? Well, anything smaller, or sorry, yeah, anything around the size of probably, what was it? The N1 rocket, right? The N1 rocket was horizontally verticated and, mobilized. So yeah, probably something close to like a Saturn V. And yeah, it just kind of depends on what sort of infrastructure you have, right? Like, it's a trade-off, as is anything in, let's see, transport, N1 rocket transport. There's a specific picture that I want to see. There it is. Yeah, that's from a PDF. Is there like just a better picture? That's also of a PDF. All of these PDFs, stop it. But anyways, yeah, let's open this up in a new tab. Where is it? There it is. So yeah, the N1 rocket, the Saturn V, the USSR Saturn V competitor, was also verticated and transported horizontally. Again, it all just depends on what you're willing to do in terms of your infrastructure. It works for SpaceX because they designed their rocket around vertical integration, because they literally want to land their rocket, catch it, and then vertically stack it. So there's no wheeling it back into a horizontal integration facility when they want to launch typically like 10 of these a day or something like that, right? So it kind of depends on what your flight cadence needs to be and what your infrastructure is, right? If you're going to vertically integrate, well, you need, you need your crane systems, and you need to have a very, very tall system, as tall as your rocket, actually taller, versus having a horizontal integration facility where you just need it wider. There's things to be said about building the infrastructure wider versus taller, and the simplicities and complexities with that. So it really just depends. But in terms of the pneumatics and hydraulics needed to lift a rocket, well, they did it with the N1, so that's at least the biggest so far, if you will. Architecture is king, yeah, 100%. Oh, nice. We got a layover here. So again, this is from NSF, wearing their merchandise chat. We have the BE4 engine thrust collection shirt on there. Definitely give them a follow or a look-see. They give us tons of coverage all the time of basically every launch from anywhere in the world. We're getting all these different multi-views from NSF, or NASA Spaceflight. But going back to what we were talking about, yeah, I really just think it comes down to what you want your infrastructure to actually be able to do, and how is your infrastructure set up, right? And if you integrate vertically, you just have to pray it doesn't rain inside the open stack. Yeah, I guess, I mean, yeah, you got to have it covered and everything, right? There's definitely complexities and simplicities about everything you do. Trade-off. Do you know what that little nub sticking out of the side of New Glenn Stage 2 is? Is it LH2 transfer tube? Where exactly? In the picture that I was showing earlier? Yeah, which was it, in the live stream or in one of the pictures I was showing? I'm curious as to why the skirt and inner stage are that brown color. So the brown color is yeah, you're talking about this? The brown color is their thermal protection system. They call it internally COMET, or COMET. Like literally all, it's a sentence case, so it's just a name. They call it COMET. It's their thermal protection system, yeah. You can see it in a bunch of the pics. I think the first one on that page. The first one on the page here. Let's see. So a little nubby boy, you say, huh? You're not talking about that, right? That's just part of the either thrust vector control system, probably the thrust vector control system. Either that or like the load bearing system. Probably load bearing system, actually, if it's attached to the outside. If I can link, yeah, 1 second. Permit. There we go. Hopefully that works. Let's see. Oh, that little guy. That's a good question. I don't specifically have an answer unless it's just some sort of fill or drain valve, because you can see in the background here that they have the strong back, or I guess the transporter rector, for filling and draining the cryogenic propellants. I can only imagine that's either a vent, although it kind of like goes into the system here, so I don't know if it's necessarily that, or if it's part of like a downcomer. Because remember, this is a Hydrolox upper stage, and what a lot of rockets that are Hydrolox do, if they don't have a common bulkhead, they quite literally have a kind of a raceway. We can actually see it on the shuttle external tank. The external tank has a downcomer for the liquid oxygen in the top because it goes around the liquid hydrogen, which is super, super cold. So it could just be that. It could be a downcomer to go into the engines from the oxygen tank on the top or something like that. But I don't specifically know. So that comment doesn't really stand for anything, just the name for the TPS. As far as I understand, it is just the name of the TPS. It's the hydrogen downcomer? Yeah, okay. I thought so. Hey Rams, how are you doing? Hope you're doing well. We call the downcomer the transfer tube at ABL, so pardon my nomenclature. Hey, that's fine. The transfer tube, yeah. I think it's the transfer tube. I think the space shuttle called it the downcomer, so yeah, to each their own. Yep, 100%. ABL though, awesome. Love me some ABL. All right, so again, this is from NSF, but we're going to continue talking through the mission architecture here, chat. So yeah, like I said, the vehicle is carrying one payload. We'll talk about that here in a moment. They're calling it the Blue Ring Pathfinder or Dark Sky 1. And yes, this vehicle is partially reusable. It is set to do a landing burn recovery on the Jacqueline LPV-1. Jacqueline is the name of what they call the Landing Platform Vessel 1. And we have some pictures and videos of that in the near future as well. So this is also launching, as I said, from LC-36 at Cape Canaveral Space Force Station. This is the 29th mission overall from Blue Origin. And of course, it's the first maiden flight of New Glenn. So we'll see if everything sticks. We have a 3-hour launch window starting here at 11 p.m. Mountain Time. 11 p.m. Mountain Time, so yeah, when this goes to 0, chat, we have 3 hours for them to actually launch. So we could be here for a while, otherwise, fingers crossed, they get the green light at the T-0 mark and we are go for launch. But yeah, in terms of the Blue Ring Pathfinder mission, the objectives are obviously the maiden flight of the New Glenn launch vehicle. They have the payload for testing a whole bunch of their different internal systems for what will become the Blue Ring orbital transfer vehicle that we'll talk about here momentarily. And they also want this to, well, this will also be the National Security Space Launch Certification Flight, or NSSL. So basically this is their certification flight for them to be eligible for launching military DoD NROL style of payloads, which is pretty big for them. So in terms of the payload, Dark Sky 1 is an OTV or orbital transfer vehicle prototype consisting of their communication system, their power system, and a flight computer, all fixed to a secondary payload adapter ring. And all of that will remain on the second stage. So none of it is separating. It's just all meant to test in a prolonged orbital flight demonstration. All of these different things that they've developed in-house, as far as I understand it, for future missions, which is pretty cool. So in terms of the trajectory, it's going into a 2,400 kilometer by a 19,300 kilometer orbit, inclined at around 30 degrees. Here's a picture of the massive, brand new, essentially, facility that Blue Origin took over and retrofitted LC-36 for New Glenn, which you see here in the background. And then they also had a whole bunch of testing facilities over here and over here as well for testing the second stage. We have video of that, which is pretty awesome. But yeah, testing the second stage, testing first stage reusability, testing, I got a whole bunch of different stuff, chat. Like LC-36 was a 2-pad system, or a double pad. They basically had a long time ago, back when they were using it for, I believe, Atlas through Atlas 3. I think it was Atlas 3 was the last one, but definitely Atlas Centaur. They basically had 2 pads operating, 36A and 36B. They took it over and basically turned it into one mega complex at 36. So this is, of course, coming from Max Evans at NSF. And then this is what the overall flight profile for New Glenn looks like. Are they planning booster recovery tonight? Yeah, they are, Sheebs. First flight, first recovery attempt. That's what they're going for. Hey, what's up, Weeby Good? How are you doing? Do you think software on these vehicles are written in C++? C++. Rust is starting to get big in the aerospace industry right now. But yeah, C++ still very much the mainstay. You know, embedded systems. That's still the standard. That's still the standard, right? But yeah, surprisingly, Rust is starting to get a lot bigger too, which is I like that. That's what I work in. All up testing, pretty much all up testing. Yeah, pretty much. So yeah, this is the overall flight profile for this mission. This was given to us by Blue Origin as well. We have liftoff of LC-36 going through ascent. We have the stage separation. First stage is coming back down, doing what they call an exo-atmospheric deceleration burn, but we all know it here as supersonic retropropulsion. We have the booster landing. It's going to be a 3-engine landing burn to land the first stage on the Jacqueline LPV-1, or landing platform vessel 1. Yeah, a lot of acronyms with Blue Origin, more than even like NASA, but anyways, we'll get through it, I swear. And then the second stage, of course, continues on all the way through fairing jettison, payload activation, and ultimately basically staying on orbit for a certain predetermined amount of time. For GS2 coasting, they're coasting for a while because they want to test their blue ring orbital transfer vehicle, all of the avionics and things that they're going to be using for future missions in that really highly elliptical orbit, so that way they can see how it handles radiation environments and thermal cycles and things like that. Such fancy terms. Yeah, much wow. Space shuttle software was written in HAL. It was written in HAL, yeah, going way back to just straight assembly language. 100%. We don't luckily do too much about that so much anymore. At least I haven't in my experiences in the aerospace industry. You work in Rust? Damn, that's cool. Yeah, I work in Rust. That's what we develop our communication systems in. I had no idea it was becoming a thing in aerospace. Yep, it most certainly is. It's bigger. There is a big company called K2 Aerospace, if you guys have heard of them. K2 Space is working on developing satellite systems specifically for Starship. And what does that mean? They're developing them to actually fit inside of the mega bay of Starship, inside of the actual payload bay. So they're sizing it to be the size of Starship. So yeah, they're developing massive systems. But K2 Space and Rust, they have been a really big proponent of Rust software development. So sorry for the flashbang here, but look, they're looking for Rust software engineers. So any of you who are looking for a job in the aerospace industry and have Rust experience, here you go. But yeah, K2 Space has been a big proponent for the Rust development. They've done a lot of like Rust events. They've been doing a lot of Rust event, what would you call it, funding or sponsorships. So yeah, K2 Space really leading the way as one of the big ones. Maybe it's time to switch from game dev to aerospace. Well, believe it or not, I would say now is a great time for that. What's up, Car Hill? Yeah, you're leaving for Rust, huh? Yeah, because believe it or not, so you know SpaceX. We all know SpaceX, right? We've seen the UIs that they have been producing as part of Dragon Capsule UI. We've seen this, right? Yeah, this. We've seen this, right? In the actual Dragon Capsule, this is what it actually looks like. This is the UI that everyone who actually flies on the Dragon Capsule sees inside of the Dragon Capsule. There, you can actually see, is that Doug or... Yeah, is that Doug right there? Yeah, all fully touchscreen, massive graphics and things like that. That's because SpaceX poaches game developers every cycle. Like every big game development conference, SpaceX is always there with a hiring booth. I'm not kidding you. Always. So yes, SpaceX definitely sees the talent in the game dev industry for developing a lot of different systems for them in terms of like UI and visual effects and things like that, which is pretty cool. Why do you prefer Rust? Because it's what I it makes sense for what we're developing. We do a lot of embedded systems, and having that safety, and we're also not doing anything that's too, I guess, complex, where I think Rust as a systems processing language for embedded systems is actually really nice. So yeah, that's what we go with. Need that safety, need the speed, and have been burned too many times on C++. Although I'm also interested in Zig. Zig seems kind of cool, but yeah. Rust immutable. Yeah, hey, like I said, I think it's another tool in the toolbox, and if you're developing something, then you can turn to Rust for certain things, right? That's a good move by SpaceX, 100%, yeah, 100%. Starship requires a production line to keep it busy, just like Starlink. Yeah, 100%, I agree with that too. Stoke has job postings for Rust people too. I wouldn't doubt that. I don't know if they're for embedded systems, because Stoke also does Stoke Fusion. They're basically a spin-off subsidiary of them, and it's a massive, what would you call it, inventory management system or manufacturing management system. It's basically, so Stoke, we all know Stoke Aerospace. They developed their own in-house manufacturing and inventory management tool, and they're now selling that to aerospace and other companies, and it's actually really taking off. Like, it's a really good tool. The slight problem I have is that I'm not a US person. That's fair. That does limit some things, sadly, although it seems like the United States government, in terms of policy for that sort of things, might be starting to relax a little bit. I'm not saying that non-US citizens will ever be able to necessarily work for a launch vehicle company, but you actually might soon enough in the next upcoming years be able to work for maybe some sort of like satellite system company. Only because they're starting to redefine policy for like what actually falls under ITAR. They're trying to make it a little bit more relaxed, so that way the United States can actually take, I guess, advantage, if you will, of being able to bring foreign talent to help with the aerospace industry, which I see as only a plus. But yeah, none of that is for certain, of course. It's just things that I've heard and seen. But anyways, chat, so getting back to our notes for this flight, because we are coming up on the 1 hour mark, and around 1 hour mark should be when Blue Origin does their start their actual broadcast. So that's pretty cool. They are lowering the barrier specifically here in Australia in the near future, from what I've heard. Yes, Australia, 100%. I think even ESA, or I say ESA, I even believe European countries as well. But Australia for sure actually has been really looked at, because Australia recently has done a lot of investment in their space platform, and they're also an ally of the United States, and there's a lot of back and forth that's going on between commercial companies, and it's like, might as well just try and make it happen, you know? What are some of the more obscure programming language you've worked with and dabbled in? My first experience was in Pascal and learned Spin, propeller proprietary microcontroller language. Honestly, not that much in terms of like the obscure. So obviously a hell of a lot of Python, and I don't mean on stream, I mean for work and for stuff like that. MATLAB, of course, did a little bit with C, C++, now do everything almost entirely in Rust. I guess Rust back at the time was kind of like the obscure one before it really became mainstream, because we started looking at Rust back in 2016. Rust has only been around since 2012, but like 2016 was when it really seemed to start taking off a little bit more. I've looked at Zig, haven't done anything in Zig. I'm trying to think, is there anything else? Is there a programming language called Turtle? There is, isn't there? I did a project in that one time in undergrad. I think it was called Turtle, right? Something like that. But anyways, yeah, not too much obscure ones, honestly. Turtle was Pascal, was it? Maybe. So yeah, back in 2016, I did an undergrad project in Turtle, because it was, well, I say it was an undergrad. I was an undergrad helping a grad student with his simulation project, and he was doing it in Turtle. Turtle Graphics? Yeah, I think Turtle Graphics. That name is what's sticking out to me from the deep recesses of my mind. So maybe I'm wrong, but I believe it was called Turtle. But anyways, chat, so getting back into the New Glenn mission that we're about to hopefully witness here. This is what we should expect from the trajectory. So this is going into a 30 degrees inclined orbit. It is set to take off here from Cape Canaveral Space Force Station in hopefully just over 1 hour from now. Now we do have a 3-hour launch window, so just because that gets to T-0, technically they could push that T-0 back anywhere between 11 p.m. Mountain Time to essentially 2 a.m. Mountain Time. So we have a lot of time to work with in this launch window, so we'll see. Hopefully everything goes really smoothly for them and they just get to the T-0 and are able to launch. Did you make these slides? No. So this, so these graphics are coming from Blue Origin. They posted them on Twitter, and I just grabbed them and put them into my note-taking app here. So the AI thinks Rust is the modern version of C, C++. I mean, I know that's what Rust Foundation wants it to be, and I think it does a pretty good job in a lot of places, but I don't think it's ever going to just replace. It's certainly not going to replace C, C++. But I think it does do a lot of good things that C, C++ obviously doesn't. But yeah, the modern version of C, C++, I mean, I guess I can kind of see what the AI that you said is getting at, but I mean, I guess that's partially true, but also partially not true. Turtle graphics were originally part of the Logo programming language. Gotcha. Like I said, maybe I'm misremembering, but I swear it was definitely Turtle that I was working in. So like Turtle graphics, yeah. But why do they have 3 flare stacks? 2 makes sense, LH2 and hydrogen. Oh yeah, I'm sorry. 2 makes sense, LH2 and LNG. So they have LNG, they have LH2. I can only imagine it's just because of the sheer volume that they require, right? Because there are certain compliance or regulations that you have to meet for burning off excess propellants or like vapor for anything from methane to LNG to LH2. And so I can only imagine just because of how big the vehicle is, they might need to meet those standards for like LNG. They might have to have 2 separate LNG stacks to meet their flow requirements. That's the only thing I can think of. Otherwise, I'm not specifically sure. Unless they have like a recondenser somewhere that's feeding into that as well as like a bleed, but I'm not sure. It's a good question. But anyway, so this is what you should be able to see if you're anywhere on the Space Coast all the way up to the southern tip of North Carolina here. You should be able to see it. You should be able to see this launch, which is pretty cool, which is going almost due east out of Cape Canaveral Space Force Station. But also, speaking of that, chat, look at this picture right here. This picture's coming from Grom. Did I get the name right? Grav Cornwell on X. This is where the landing platform vessel 1 is. This is where Jacqueline is. It's 620 kilometers downrange, over 320 miles downrange. Yeah, this thing is very far away. First stage is going to be going super fast on re-entry, chat. But yeah, it's going to go all the way down here for the expected landing and recovery. We'll have to see, of course, if that sticks. There's a lot that has to go on here. You're in Tampa? Well, there you go. You should be able to see it between 90 and 120 seconds. So there you go. Wait, no, I'm sorry. That's 1, that's 2, that's 3. So yeah, you should be able to see it within 120 seconds or so from launch if you look east. But yeah, this thing, like I said, is going very, very far downrange. The landing vessel itself is 620 kilometers downrange, 320 miles, roughly speaking. It's crazy. Like I said, the scale of this vehicle cannot be understated. You're thinking about going, but it's so cold. It is a little chilly. Is it chilly in Florida? That seems like an oxymoron, but yeah. I'm just out of range, sad face. That is a little bit sad. All right, chat. Well, that's kind of like the overview of the actual mission itself. In terms of what the actual payload looks like, it's right here. Chat, look at that little guy. So yeah, they have a massive 7-meter diameter fairing for this little guy right here. Look at that little guy. Look at that little guy. If you're wondering what this is basically just an ESPA ring. So if we go here and look up an ESPA ring, it's basically this. It's what every launch vehicle system uses as a way to host a bunch of different payloads on the side. It's basically a standardized adapter that's designed to fit into whatever payload attachment fitting. And it's just a structure element that gives you different ports. These things on the side are called ports, and you can fit a whole bunch of smaller assets on the side. Anything from and what's known now as an ESPA class satellite, anywhere between a CubeSat, which can be on the order of centimeters wide, all the way up to something that's on the order of 750 kilograms or larger. But yeah, this is essentially what they're developing. Actually, what they're essentially developing is something like this, which is Northrop Grumman's ESPA Star. It's, like I said, it's basically one of those vehicles that's designed to separate. It has a propulsion system, it has avionics, it has power generation, and then you can just fit a whole bunch of payloads around that ESPA ring port, and you can fly those payloads anywhere. That's what they want to do. This is what Blue Ring is designed to be. Do we actually have a better picture of Blue Ring of what it actually, yeah, there you go. So like I said, it's basically just an integrated payload attachment fitting with a whole bunch of room for power generation, for propulsion systems, and then on the entire side, all the way around it, you can fit a whole bunch of different payloads. And then this thing is designed to do what's known as a last mile delivery. Basically, New Glenn, right, takes a rideshare payload up to, say, in this case, 2,300 kilometers by 19,000 kilometers. And this thing would then separate with a whole bunch of different payloads and maybe take them into geostationary orbit. That is really, really beneficial because typically speaking, when you think about the SpaceX transporter missions where they carry on the order of 100 different payloads on one SpaceX Falcon 9 flight, all 100 payloads basically get dropped off into the same exact orbit, which sucks if your vehicle needs to go into a slightly separate orbit, whether higher or lower or different inclination, because otherwise you would then basically have to go to Electron from Rocket Labs and buy a dedicated flight. So an ESPA ring for SpaceX costs around $3 million per port for a 700 kilogram vehicle. If you were to take that same 700 kilogram vehicle, well, actually that 700 kilogram vehicle couldn't even fit on Electron. But you would basically go from, say, a $3 million price tag for a launch all the way up to a $9 million price tag for Electron for a dedicated launch. So this is where these sort of last mile delivery vehicles really shine. They're also known as orbital transfer vehicles because you could fit a payload or a bunch of different payloads on them, and then they can go to different specific orbits with its own propulsion system and drop them off at where they actually are required. So that's what Blue Ring is supposed to be. There's a really good picture or render of it here. And this is what they are essentially testing here tonight, which is a prototype vehicle, which has basically the communication systems. You can see the communications here. They're basically cone antennae. And then they also have, I believe, an avionics package and a power package as well on here that they're all testing. How much Delta V is the Blue Ring supposed to have? I have no idea. I don't know if they've actually specified. Let me actually see. Let's go back to that page and see if they have a specification. Blue Ring. Oh my God, I cannot type right now. Blue Ring, Blue Origin. We go here. Do they have here unprecedented Delta V capabilities? In-space computing, payload capabilities, 3,000 kilograms, by the way, it's no joke. And then inquire. So they don't have any numbers there. Does anybody else have any numbers anywhere? Design year 5 years. Doesn't look like they specify any particular Delta V yet. So not sure, but it seems pretty big. And with the 3,000 kilogram capacity, yeah, That's it's not small at all. But yeah, I don't know. That's a good question. Hopefully we'll learn more about that in the future. But anyways, that's what we have now. They're just doing this to test some of the avionics and other systems. They talk about in-space computing too. Yeah, can you imagine just being able to, oh, you know, I have this flight software package that I want to check out for my future satellite. Can I send it up to Blue Ring here and have it tested? That's pretty awesome. Or if you have a payload on board, being able to upload like a, you know, an image processing system to work with your payload and actually be able to do all of that really high computational systems right there on a orbital platform. That's pretty cool. That's pretty cool. I wonder what BO's broadcast will be like. Hopefully better than the Shepard ones. Yeah, I don't know. That's actually a really good question, but we'll have to see here in about 4 minutes or so. So what happens to the transfer vehicle after it drops its payloads off? Well, it says it has a 5-year design life expectancy. So either they just leave it up there with maybe some tertiary sensors and whatnot and use it as a demonstration platform for, like I said earlier, what if you were developing a flight software to control your next satellite and you would love to test it? Well, you can upload it to Blue Ring, who now has nothing to do but stay there, and have it take over that control system and be able to test certain parts of your controllability. Or, you know, if you are developing, if it can have some sort of tertiary sensors on board, be able to upload your fault management system for your next satellite or spacecraft and have it tested in orbit on a flight computer with all the sensors being fed into it as well. Like, there's a lot that it could technically do, but it has a 5-year life expectancy. So if it has integrated payloads, not just deployable payloads, that's another thing, right? Like, think about Rocket Lab's upper stage, right? Its upper stage platform is designed to either just ferry a vehicle into its destination orbit and then separate and then deorbit, or you could just use that same platform, have permanently integrated payloads on there, and then it becomes a satellite. And it just becomes a satellite with payloads on board, which is pretty cool as well. What are the advantages of the Ion engine's position on the Blue Ring? What are the advantages of the Ion engine's position on the Blue Ring? Ion engine position. I did not see any Ion engines. Was that on the page that we were just looking at? All right, so we have roughly 2 minutes here. Let's see here. Blue Ring, Blue Origin. You said it had, oh, these guys. Oh, I didn't even notice these. I wonder if it's just honestly a render. Oh no, it is permanent. Okay. But yeah, in terms of its positioning, I would assume that it's for, well, you have multiple engines, so that way it can actually have some meaningful thrust, so that way it doesn't take a year to get to its destination orbit, right? And then also, I'm sure all of these in some way, shape, or form, like this one here probably goes through the center of mass, is probably slightly canted. Goes through the center of mass. It also looks like these are both offset a little bit, which is kind of interesting. Like, it looks like that engine there isn't actually through the center of the structure. So it probably has something to do with like that. And I wonder if this is also gimbalable. It kind of looks like it might be gimbal capable. But yeah, it's probably just how everything can fit together from a mass perspective to really keep it mass in alignment, right? Because if they, you would really like to not have to waste your RCS control, your reaction control system, your propellant for RCS or for attitude control, just while you're thrusting with electrical propulsion. So you definitely want to make sure this is all in balance. But yeah, we should be just a few minutes away here from the New Glenn NG1 Blue Origin cast. We'll have to see what that comes to be. Probably don't need to gimbal if you can vary the throttle between the three. I'm just thinking of like what happens if one goes completely out, right? You would probably want them to gimbal, because if one of the side ones go, then you can't use the other one, because you're always going to have that slight either that, or, you know, it is electrical propulsion, so it's low thrust, but do you really want to saturate your reaction systems or use RCS every now and then to keep yourself stable? I don't know. Now they're making a whole bunch of gimbal systems. Like, if you look at Rocket Lab's offerings now, they actually have gimbal systems. Basically just servo actuators that allow like very small payloads to gimbals and stuff like that, which is pretty cool. So I feel like that's kind of like where the aerospace industry is going to some degree. Does Blue Ring have gyros? I can only imagine yes, because it has full attitude control. So I would think if it's like a satellite platform, so to speak, that it would. How often it would use that, especially when it has many payloads on it? Not often, but I'm sure I would like to think it would still have that. Oh yeah, here's a great picture that we got to see on XChat. This is a picture of the New Glenn Blue Origin Mission Control Center. Looks very nice. Can't wait to hopefully see this on the live stream. But yeah, this is their control center. This is like the first peek that we got just this last couple of weeks or whatever. Yeah, got the good chairs, the ones that are like $1,000 a piece with that lower back support, chat. Stay here for hours on end. Yeah, very nice. Looks like a lot of Pi GUI used, which is fantastic. Yeah, so we got some really good sneak peeks here. And then if anybody was wondering what is the system that is going to catch our vehicle tonight, and yes, I am being purposefully optimistic, New Glenn is going to land right there. Look at this. This is Jacqueline. You can tell it's Jacqueline by the way that it is. Yeah, this is the new, this is the Blue Origin's version of basically a SpaceX barge. Can I, add just how wild it is? You can tell the confidence of Blue Origin, because look, they still have massive, I don't know, structures on board that actually house different capabilities and actually look like they can house humans and stuff as well. So in comparison to just a barge that has literally nothing but a landing zone, Blue Origin has actual structures and internals and things like that, which is kind of interesting. So, but yeah, that's Blue Origin. That is the massive crane right there that we saw them lifting a few weeks ago, the current New Glenn vehicle up. So that seems good. Ooh, they have a countdown here. One second, let me go back to this. Can I, hello, can I go back? There we go. So replenishment begins. So right now, in terms of, again, this is NASA spaceflight, otherwise known as NSF. We have done stage 2 hydrogen loading. Stage 1 locks begin. Stage 2 locks begin. We have booster liquid natural gas loading begin. Propellant loading complete, according to their timeline. So basically at this time, about an hour from flight, they have the entire vehicle, it sounds like, loaded. And now they're just going to do what's known as stuffing the tanks or replenishment, because it's a fully cryogenic rocket, right? First stage is liquid natural gas, which is essentially cryogenic methane with some impurities. It's not like lab pure methane like we have with Starship. So they call it liquid natural gas. So it has some impurities, but it's fine. It's mostly methane. So we have liquid natural gas in the first stage and liquid oxygen, but then also in the second stage, we have liquid hydrogen and liquid oxygen. So it's a fully cryogenic vehicle. So basically now it's going to constantly start boiling off. They're going to constantly be managing pressure, as it's called. We can see vents on the side of the vehicle here, and there might be one on the transporter here as well, but definitely here at the top there's 2 of them at least. And then they probably have the recirculation, what would you call it, recirculation lines to go to the stacks that are over on the side here, for that you see the big fire in certain viewpoints, because they're literally burning off gaseous gaseous natural gas and gaseous hydrogen. So all of that, of course, is going to be constantly boiling off, so they're going to be constantly stuffing the tanks or refilling it. But yeah, it looks like we are basically in a state where it's fully fueled, chat, which is pretty cool. Wonder what the cost of liquid methane versus LNG is. LNG is, to my understanding, much cheaper. Like, yeah, you do have some impurities, right? It's not like liquid methane, when you call it liquid methane, is like 99 point whatever % methane. Liquid natural gas is, call it like 98% methane, or, you know, something like that. So there's some impurities, but those impurities versus the cost and everything, especially if your engine is designed to manage those impurities and those different conditions, totally fine. Like totally totally nice to be able to use liquid natural gas versus liquid methane, because you can literally tap into the massive United States liquid natural gas or natural gas production infrastructure versus having to go and set up your own specific line of methane deliveries. But anyways, Apollo coming in with a Twitch Prime sub. They've been subscribed for 11 Kerbal years of support. Oh, nice. They have that, they have an animated view of what I was showing here earlier. Basically an animated view of this picture up here. There you go. Again, this is going to be the flight path for this mission. So if you're in the along the Space Coast here, you should be able to see the launch all the way up to the southern tip of North Carolina and all the way over to the panhandle of Florida. So yeah, you should be able to see it. If you're anywhere in this big old oval here on line 8, you'll be able to see it at 240 seconds into flight. I'm watching from Atlanta, Texas. Well, hello, Christy. Welcome to the stream. Of course, I still love you. Well, I still love you too, Frizz Kappa. But yeah, so the whole thing with liquid natural gas, I'm happy to see Blue Origin went that route, because like if it's truly liquid natural gas, and if you go to different places on the internet, you'll see that it's actually just liquid methane, and you know, just Blue Origin sometimes refers to it to liquid natural gas. But I'm hopeful it actually is, because if it is, it's kind of a smart move, because yes, you have some impurities and therefore some combustion inefficiencies relative to just pure liquid methane, but you don't have that big of a performance hit, because the energy density of liquid natural gas is, you know, super close to just pure methane. And then also, like I said, you can tap into the massive production infrastructure that's already existent in the United States for natural gas, so you don't have to worry about like sourcing lab pure methane, which is kind of interesting. Yeah. What's a little soot between friends? Yeah, 100%. But yeah, so this is another really cool graphic that we got from Blue Origin. Again, like I said, New Shepard can comfortably fit inside of the New Glenn fairing. It's a 7-meter wide fairing. It is 2 stories wide in comparison to how big a 2-story building is, right? Like it's 2 stories tall as it is wide, which is pretty crazy. Overall, the system is able to utilize 2 BE3 upper stages. This is the size comparison roughly between the BE3PM or propulsion module for the New Shepard vehicle. And then, of course, the first stage is using a whopping 7 BE4 engines, each one producing 2,450 kilonewtons of thrust. That's like 550,000 pound force for those of us who don't work in the metric system, all combined with 3,850,000 pound force thrust for the first stage engine. That's like 17,000 kilonewtons, 17 meganewtons, chat, which is just wild. It's so much. And there's the beautiful rocket that we have flying here in just a short amount of time. 55.5 megajoules per kilogram for methane and 50 megajoules per kilogram for liquid natural gas. Nice, thank you for those specific numbers. Awesome. So yeah, like I said, in terms of the grand scheme of things, when it comes to cost and, you know, ease of procurement and usability on your system and whatnot, liquid natural gas can certainly be a good drop-in replacement. Do we know about what staging altitude will be? The graphic makes it look like it'll be pretty high. You know, I don't know if we actually know. Because of course this isn't actually showing staging, this is just showing, you know, roughly the final orbit. No, actually this isn't even showing the final orbit. Like the final orbit is this. The final orbit's going to be 2,300 kilometers at periapsis and 19,000 kilometers at apoapsis, so very tall. But I don't know if we have a specific number from them on where separation will actually occur. It's enough to push the first stage 600 kilometers downrange, so there's something to be said with that. But I wouldn't really think it'll be too much more than what like a Falcon 9 is, just because, you know, of the mass and everything, although it is liquid methane, so it'll be a little bit more efficient than what Falcon 9 can do. But maybe on the order of like 120 to 150. But yeah, that's a good question. I don't know. Will they slap a new Shepard with crew on New Glenn at some point? Will they slap a new Shepard with crew on a new Glenn? Oh, I see. So like this here, are they going to do this someday? Probably not. No, I don't think so. That sounds bad. Although it is a hydrolock system, liquid hydrogen and liquid oxygen, and so is the upper stage. So you literally at the very top of your system have all of the piping already required to fill up a new Shepard upper stage. Oh, that's true. It is also like completely empty of payload. Like the payload that we have is a couple hundred kilograms. Not even, it's definitely not 1 metric ton. So, and this thing can carry 45 metric tons into orbit. So yeah, you're right. I did not take that into account. Yeah, so it might go pretty high or pretty far. What a great view, chat. What a great view. I don't know if the original poster was a guy called Blobifi, but that's that picture was from the Blobifi account on X. But yeah, just a great picture overall for this one. Payload negligible, indeed. Yes, indeed. I hope they end up painting that bronze color. You know, honestly, I kind of like the bronze color. Like up close, yeah, up close it looks a little meh, but from like farther away, I think it really I kind of dig it. What is a kilometer? Cue America sounds. Yes, exactly right. Dang, new Shepard payload, put it in perspective. Huge. Yeah, like we showed it earlier. If you guys haven't seen it, there it is. That's it right there. That's the payload. Yeah, this is the payload. It's just a payload attachment fitting. It's an ESPA ring. It's an ESPA port. These things are like only a few hundred kilograms typically, depending on the size. Like, not much. And it of course has systems on board. It has a communication system on board. It has an avionics package on board, and it has a power system on board, I believe. But even that, like, I don't expect this thing to be more than probably 500 kilograms. But look at that massive fairing, chat. That thing is huge. Like I said, this dimension right here, from this side to this side, is a 2-story tall building. That's 7 meters. That's 23 feet wide. Yeah, it's a 2-story building. Long ways. So that's pretty crazy. So here we can see Blue Origin doing some integration. This was they were taking off the kind of like dummy payload, if you will. This was just a dummy structure for the fairing when they're doing fit checks. And here's the actual payload with the integrated payload. Here's the integrated fairing with the payload in the horizontal integration facility. Here's the upper stage with the twin BE3U engines, each one pumping out 700 kilonewtons of thrust, which is pretty insane. And there's 2 of them, so that's pretty good, pretty solid, chat. I think combined it's like 160,000 pounds of force, which is, yeah, like I said, the scale of this thing is a monster, chat. It's an absolute monster. People for scale, by the way, in the foreground. Yes, 7 BE4 engines, chat. Each one 2,400 kilonewtons. By the way, these are more powerful than Raptor 2. Just putting that out there. Not Raptor 3, obviously not. But yeah, more powerful, more bang than the Raptor 2. Although technically speaking, these are also like 2 or 3 times the size as a Raptor 2. But you know. There's a trade-off, chat. There's a trade-off. But yeah, absolutely wild. Here's another, you know, a massive Ford Super Duty in the foreground for scale. 2 SPMTs required. Here's another great picture of just how massive this vehicle is. It's wider than a 2-lane highway, and it's definitely longer than an entire extended intersection with 5 lanes across. It's pretty big. BE3s are the superior RL10. I agree. What's interesting, and we can talk about this in a little bit, is I'm pretty sure the BE3U is an open expander cycle, and we can talk about that here in a moment because I do have some notes on that. Here's the closer look of the Blue Origin fairing that's going to fly. You see this ring here, Chad, this band where it says "for the benefit of Earth." These are signatures of Blue Origin employees, which is pretty awesome. There it is in all of its massive glory. Here we have the vent holes at the bottom. So these vent holes are there for a reason, because you do not want, as your vehicle is ascending into the atmosphere, to still hold 14.7 pounds per square inch or 100,000 pascals of pressure inside of this vehicle as it's ascending up to a vacuum. So you of course have vent holes to make sure everything can evacuate. And there's the payload. But yeah, so what I was talking about in terms of the engines, which is actually really cool for the BE3. Oh, yeah, there's Jacqueline. Jacqueline's pretty cool, chat. Jacqueline's gonna be super good. Yeah, here's a BE4 engine for size. Engine size comparison. We have multiple people for scale. Official stream is live. Awesome. Thank you very much. Let's see what we got here. What do we got for the live stream? All right, cool. So nothing yet. So we'll keep that on the background. I'll mute the music there, and we'll listen to this so we can catch it exactly when they start up. But yeah, there's a BE3 engine for scale. Absolutely enormous. It just, yeah, 2,400 kilonewtons each. Oh no, okay. For a second, I thought they were those were mic static, but no, it's just the music. Oh yeah, so here's Blue Origin that we saw earlier this year, I think, like summer, if I'm not mistaken. This is coming from NASA spaceflight as well. This was them testing fairing recovery operations. Yeah, so they took this massive crane. Here's the turnaround basin at Cape Canaveral Space Force Station. Literally just took a massive test article fairing, laid it in the water, see how it floated and whatnot, and then tested how they would pick it up and move it around. So that's pretty cool. Having stood next to an F1 engine that's comparable, yeah, it's large. It's very big. I think I want to say it's like 80% the size of an F1 engine. Like, it's very big. Yeah, like I said, this thing produces more thrust than a Raptor 2, if I'm not mistaken. But also, it's like twice the size of a Raptor 2. So, like I said, there's a trade-off. There's a trade-off. Because I think this thing operates at around like 130 bar chamber pressure, whereas a Raptor 2 operates at like 300 bar. So, yeah, and the higher pressures that you can operate, the more thrust you can get with the smaller engine. So, yeah, it's a big difference. And then what I really wanted to show, oh yeah, there's a BE3U engine for scale. This is just the power pack, by the way. The nozzle extension is huge. Like, this is just the top of the rocket, and then the nozzle extension comes all the way down. But yeah, the power pack itself is as tall as like a person, just to show just how big this engine is. And this is the upper stage engine, like I was saying. It's pretty big. Oh, that was that. Okay. So what I wanted to get at here was the BE3U technical specifications. So yeah, 700 to 707. These, I think this was the number that Jeff Bezos gave us, but I think the official Blue Origin post said it was around 712 kilonewtons. But regardless, you know, 50 kilonewtons, give or take. That's roughly what, 30,000 pound force difference, give or take. Because it is a Hydrolox engine, it has 445 seconds of specific impulse. Specific impulse, of course, is your fuel efficiency. It's essentially your miles per gallon. Quite literally, it is how much thrust you can get out of 1 kilogram of propellant. So like how many kilonewtons of thrust you can get out 1 kilogram of propellant, that sort of thing. So pretty good. Or rather, how much impulse you can get out of 100 or 1 kilogram of propellant. Yeah, something like that. And then This is the cycle as I understand it. It's known as an open expander cycle or expander bleed cycle. Now, what's interesting is that this cycle here, if we know the RL10 is a true expander cycle. It's all closed. The difference between open and closed, a closed system basically has all of the fuel from your rocket tanks going through the throat of the rocket engine. So you basically have all of your oxidizer going into the combustion chamber, and you have all of your fuel going into the combustion chamber. That's known as a closed cycle. In this case, we have an open expander cycle, where technically speaking, some of the either fuel or oxidizer is actually dumped overboard. Why would you do that? Because, and this is just my opinion, but it seems very much like roughly the maximum thrust capacity that you could have out of just an expander cycle is around an RL10, which is like 120 kilonewtons. I think technically you could probably stretch that design up to 200 kilonewtons of thrust, but that's roughly, I think, in my opinion, the maximum that you can do with a closed expander cycle. Now, why is that? Because the way an expander cycle works is that you have your propellants having to go through the channels of your rocket engine nozzle and combustion chamber to basically soak up some heat from the combustion process, turn that very, very cold liquid hydrogen or liquid oxygen into a more supercritical fluid, something that's near gas or even partially gas, so that we can then turn your turbopumps. But in terms of how big of a rocket engine you can take with that, and how big of, in terms of the combustion chamber pressure that you need in order to achieve that thrust, you're asking for a lot. You're asking to take on a lot of heat absorption into your super cryogenic liquid fuel and oxidizer in order to basically all of that go into your combustion chamber. You're basically losing too much pressure by having all of your fluid go through all of the different channels of your rocket engine. What an open expander cycle does is it actually bleeds off some of the air or some of the fuel or oxidizer, whichever one you're actually using to cool the rocket engine. You're bleeding some of that off to actually then run the turbine, which allows you to keep that at a much higher pressure to then enter the combustion chamber, and then the rest of it just gets dumped into the nozzle downstream of the throat. So if you're asking yourself, is this less efficient? Technically, yes, because the most efficient use of a rocket engine is to, again, have all of your combustion byproducts go through the throat. But what's really interesting here, chat, is that when you talk about an open expander cycle, because you're not talking about having such a massive pressure loss going through your lines for all of your fuel and oxidizer, it means that you can have a much higher combustion chamber pressure, which actually picks up a lot of that inefficiency of dumping some of your fuel overboard. So that's why you can actually have a bigger expander cycle if you can go with an open cycle or a bleed cycle, because you can actually maintain that combustion byproduct pressure all the way through your lines, and then you still get some good performance out of just doing this dump here into your nozzle, because again, you're still having all of your propellants going through the nozzle and being accelerated out of the back. It's just not going through the throat and getting going supersonic. So it's kind of interesting. It's an interesting trade-off, but this is what I think allows them to have a 700 kilonewton combustion chamber, or sorry, a 700 kilonewton engine with an open expander cycle. It's kind of interesting. It's a really interesting hardcore engineering, as Frizz said. There's always trade-offs. There's always different ways of doing it, and in my book, this is a slightly unintuitive way to do this. Like, okay, how do we have a really efficient engine that works with hydrogen and oxygen, as the case is with the BE3U? How do we have a really powerful engine while still maintaining a lot of efficiency? Well, there you go. I think it's a superior design. I like it. This is definitely one of the first of its kind, if I'm not mistaken. Like before the BE3U, I hadn't heard of an open cycle, an open expander cycle. I mean, I've heard of it, but I didn't, I guess, fully understand what that actually meant. You know what I mean? So it's pretty cool. So they dump the heat along with dumped fuel. Partially, yeah. So in a typical expander cycle, we can actually look at the expander cycle, right? The typical expander cycle. A typical expander cycle you have your fuel basically going through the cooling channels of your combustion chamber and rocket engine nozzle. It picks up the heat as it goes around the combustion chamber, and then that goes into a supercritical fluid, very, very close to gas, or even has two-phase flow, gas and liquid, and that's able to then be picked up by the turbine to actually start spinning the turbine, and that's what spins your turbo pumps. So very, very efficient, right? Because you're not using like a pre-burner or gas generator, which is burning some of your byproducts, and having that heat be lost in comparison, just being able to use that to turn your turbine. So there's, you know, a few efficiencies that happen with an expander cycle. Very, very efficient method, because very few moving parts. You just have your turbo pump that's moving. You don't have bleed valves going into a gas generator. You're not burning different byproducts that's not in your combustion chamber. There's good things to happen here, right? So very, very simple engine. So you have something like this, and then your oxidizer just goes straight into your combustion chamber and meets the two-phase flow, the supercritical fuel that's run through the turbine, and you have combustion, and therefore you have really pretty good efficiency. But then when we were looking at ours here, we have the open expander cycle, where now we have our fuel getting capped off to run through the heat exchanger to then go through and spin the fuel turbo pump and oxidizer turbo pump, and then all of that tap off then goes as basically into the nozzle, where the rest of it goes straight into the main injector after being spun by the turboprop to meet the oxidizer to then do your combustion in the combustion chamber. So there's just a slight difference, but that difference can be all the difference for maintaining pretty good efficiency at a much higher thrust capability for an expander cycle. And that was the end of the music. Are we actually going to get live stream stuff here now? No, they're replaying it. They're replaying it. Yeah, somewhere on the order of 33 minutes, so long as they stick to it, chat. Yep, 11 p.m. Mountain Time. We are inching ever so closer. We have some great shots here coming from NASA Spaceflight. They are providing us these shots from multiple camera angles as well. But yeah, we also have the New Glenn live stream from Blue Origin up and running as well. So yeah, not bad. Not bad. Can I go full screen here and see this? I can. Heck yeah, chat. Picture in picture time. Beautiful. So yeah, this vehicle has been in development for almost 10 years. Chat, if this thing lands tonight, it will have been over 9 years since Falcon 9. Falcon 9 is still the only one that has done a reusable first stage landing. Propulsive landing, I should say. Because I guess technically Electron did a landing, but not really a landing. But yeah, so this will be the first time in over 9 years that a vehicle has propulsively landed for a reusable first stage. And it seems like every single launch vehicle provider is working on reusability, but we still haven't had any others. We haven't had any others actually enter the market. Rocket Labs has done it, but they actually haven't reused one yet, right? Will you eat your pants if it happens? No, I will not. I'm actually really rooting for them. I think a lot of people, because I think somebody in our Discord asked that question about, like, what do you think the probability is of oh, do we have, oh no, I gotcha. This is NSF host here. For a second I saw that and I was like, did the live stream actually cut to somebody talking? Yeah, somebody in Discord asked if what the probability is, so to speak, of this actually being able to land. And I honestly think they have a pretty good shot. because we definitely do need to take into account that Blue Origin has a lot of experience landing rocket vehicles. They've done it with New Shepard. Now, yes, there's obviously a difference between landing something like New Shepard on a static landing pad on a vehicle that can fit inside of the fairing here, but they do have experience with that. But also, Blue Origin has very much gone a different route to SpaceX.
Cornell, Vice President of Blue Origin's In-Space Systems Business Unit. I'll be bringing you all of the action of New Glenn's first launch. We're here in Cape Canaveral, Florida at Blue Origin's Rocket Park.
Look at that mission control chat. Hell yeah.
Got mission control over here, launch control right down there. And tonight, for the first time, New Glenn is taking off. Just 8 miles that way from our launch pad. And we don't just launch New Glenn from Florida, we also build it right here. So the one that's out there on the pad tonight, it was born right here in our rocket factory. And as you can see, we've got several more coming down the line right behind it.
Yeah, they already have multiple.
All right, it's game time. Denise, my co-host, you ready?
Because don't forget, they have a Mars mission this year with NASA.
Leads for the New Glenn program. Let's light this candle.
Let's do this.
The human need to explore is deep within all of us. Our ancestors crossed mountain ranges, sailed
We're under
open
30 minutes,
oceans
chat.
to map new lands. and
It's
sought out
Gwen's
the
sister.
unknown, while always looking to the stars. We're curious. And now we're at a
Oh,
place
Blue
where
Moon
we
is
can
also supposed to
pioneer
happen this year.
new horizons.
Or start happening this year. I've said it before. I really think 2025 is going to see Blue Origin basically like SpaceX prop up in 2015 with their first landing attempt. I think Blue Origin is going to take 2025, and at least I'm hopeful that they're going to take 2025 and really come out on the other side as a very prominent figure, because they have Orbital Reef. That's their low Earth orbit station, set to start working towards that goal this year. They have Blue Moon cargo lander that's supposed to happen. They obviously have New Glenn that's supposed to debut. They have a Mars mission with New Glenn set to take off as well. And they have a brand new capsule and tail that is supposed to happen here for space tourism. So they have a lot going for them in 2025. Let's see if they can capitalize on it. Hello? Ah, there we go. Wrong button.
Welcome, everyone. It is a beautiful day to launch our new rocket. Denise,
Look at that
thank you so
chat
much
in the
for joining me.
background. So you got
Thank you,
another
Ariane.
first
I
or
can't
second
believe we're
stage in
here
the background, and
together.
then you
have
also
so
had
many
the
years of hard
forward
work across
module.
all the teams at Blue Origin to bring us here today.
I like
And
the backdrop.
A warm welcome to everyone watching. I've been at Blue Origin for 4 years, and I just got to say, I am so thrilled
Oh, look,
to be here.
you can see the script.
Speaking my language,
You can
girl.
see the script,
Denise,
chat.
You're one of our principal engineers on the New Glenn program. I'm looking forward to your insider perspective
right here.
as we go through launch. What do you think you're most looking forward to tonight?
So many things, but I think for me, hands down, it's going to be
So
the
this is
noise.
the
You know, New
forward
Glenn is
module.
just so
It's
big.
basically the
Those
inner
E4
stage on the very,
engines
very
are
top of
so
the first stage.
powerful, and it's so close to us. I really think that people all up and down the Cape and Cocoa Beach
I
are
can't
gonna see
unsee it,
something
chat.
brand new today. And yep, that's what I'm here for. I'm going to bring some insider technical content as we go. You know, in my role at Blue as the principal contamination control engineer on the New Glenn team, I'm going to try to provide.
That'd be pretty-
all those
that'd
cool
still be pretty
details
good,
that
Stealthy.
folks might want to know.
Yeah, the teleprompter, yeah.
With me today. Thanks so much. You've been one of many team members working extremely hard on this vehicle, so this is a big day for you and the team.
And what a day for you, Ariane. Congratulations on your baby girl. Welcome back from maternity leave.
Thank
Oh, very
you.
cool.
I'm very happy to be here for New Glenn's first launch. Absolutely no way I would miss this. I had my beautiful baby girl just a couple months back, and
Heck yeah.
now I feel like I'm back for the birth of my other baby back here, New Glenn. But before we get in a little too deep into the show, I do want to take a moment to acknowledge the devastating fires in California.
Fingers crossed, Cecil.
We
I'm
hope that
glad you're
everybody
enjoying
remains
it.
safe, and we want to send our deep appreciation for the incredible
Patrick Stewart,
work
that'd be pretty
of
crazy.
the firefighters and emergency workers battling these fires and caring for so many people. We at Blue actually have a few
Right on.
hundred employees in the great state of California, many at the center of it all.
We are Team Blue, and our hearts are with you during this difficult time.
Well said. Now, with that, let's turn our attention to the star of the show today, New Glenn.
Come on, I want to see some close-up pad pictures. Oh, there it is.
Launch Complex 36.
Nice.
There it is, standing tall. And you know, we've got plenty of cameras all around the pad, so we're going to get some great views today.
Heck
That
yes.
rocket looks good.
It
All
really
right.
does.
Why don't
See,
we
it looks
start,
really
Denise,
good in
by
this
giving
light.
us
It
a
looks
tour of
like
the vehicle?
bronze.
Well,
Like, I
New
really kind
Glenn
of
is
dig
Blue
the
Origin's
look of the
next-generation
TPS.
orbital-class rocket, and it's built on a reusable first stage.
And speaking of reusability,
Exactly,
let's
Dan.
look at the aft section there of New Glenn. One of the things that is
So here you can
critical to
see
New Glenn,
the,
of course, because it's a reusable vehicle,
not
is
only are these the
landing
clamps
legs
to the
that
top of
house
the rocket, but they're also
section
the
there.
So there's
propellant
actually
loading
6 landing legs on that aft
systems as
section,
well.
and they're actually gonna
There's
deploy
another one here you can
right
see.
before it lands.
So we have both first and second
Unlike New
stage.
Shepard,
Second
our
stage probably being
suborbital
filled at the
vehicle,
bottom as well.
New Glenn's
Or
booster
sorry,
is
yeah,
going
first
to
stage
land out
filled at the bottom.
New Glenn is going to launch vertically here at the Cape.
How long will
It'll
this remain
then
shiny?
arc over the
Hmm,
Atlantic
good
onto
question.
the orbit.
We don't know
First
anything about the
stage is then
TPS.
going to maneuver its way back to Earth onto a landing platform that's actually positioned in the Atlantic Ocean. Now, the first stage booster is powered by 7 BE-4 engines, and these are really powerful engines.
What is it
Each
venting?
one is capable
Liquid
of over
oxygen.
500,000 pounds
It's venting
of
liquid
thrust each.
oxygen.
So when we combine all 7,
This is a
we're
fully
talking about a launch
cryogenic vehicle.
with a thrust at liftoff of nearly 4
So it's using cryogenic hydrogen and cryogenic oxygen in the upper stage, and then it's using cryogenic oxygen and cryogenic liquid natural gas for the first stage.
And as the first stage is busy
nice.
landing back on Earth, meanwhile, the second stage is going to continue into orbit. Just for a quick intro for those
So that
are
fire
not,
that you saw there,
know,
they have to burn off the fuel because liquid natural gas as well as liquid hydrogen are very volatile, and they also, I think, or at least liquid natural gas definitely does. I think hydrogen does as well. They have regulations on just being able to vent hydrogen and liquid natural gas into the atmosphere, so you're supposed to burn it off.
2 BE-3Us. Now, these are actually an upgraded design based on the liquid hydrogen and liquid oxygen engines that power New Shepard.
Does BO have any
And then,
orbital
of course,
reentry vehicles?
there's the crown
I'm not
of the
sure.
vehicle,
I mean, they
if
have
you will,
concepts.
the payload fairing on top.
Yep, that's my favorite part, the payload fairing. It sits right on top of that second stage, and it's really a protective cover that takes care of our payload.
Thing is
on its
massive,
way
chat.
to space. But it's really what's inside the fairing that's at the heart
Like I
of
said,
every
this
New
thing
Glenn
can
mission.
fit a New
right.
Shepard
So
vehicle
Every rocket
comfortably
launch
inside
is
of it.
about sending something to space, and today's launch is no different. For this first mission, that payload is a pathfinder for another Blue Ring program, Blue Ring. It happens to be very
Another Blue
near
Origin
and dear to
program,
my
Blue Ring.
heart, because it's the program that I help lead. But before we get too deep into that, I am thrilled to say
Ooh,
that we've got a
nice.
couple
Oh,
other
we're going to see
faces
such a
to
great
meet
payload
this
fairing
evening, bringing us
separation.
all the action. So, first,
Oh, that's gonna be
I would like
so
to
good.
Bring in my teammate Maggie McNeese.
That's inside the
from our
fairing looking
government
up.
team in DC. She's standing near mission control now. Maggie, you there?
Hey Ariane, hey Denise, we really doing this?
This is happening. We are definitely here at launch day, and
Looks
you
like the
have to be
inside of the
feeling some
Zeppelin,
the
you're not
same
wrong.
tingles we are down here. Why don't you situate us to where you are?
Favorite of
standing up there?
2024,
What's going
probably
on?
Flight Test 5 Starship.
What's the vibe up there?
The vibes are impeccable. I am here by mission control. Right down the hallway, as you said before, we've got our launch control. In these rooms are our engineering teams and operators who are going to go ahead and
Look at that mission
looking
control,
at all
though.
of that data coming off the vehicles. They're gonna
Oh,
give us
look,
our
you can
best
see
chance to success
Jacqueline. This is
today.
the recovery boat that's
We've got
downrange. They call it
pretty special
LPV-1
assignment
or a
for you
landing
there,
platform
Maggie.
vessel 1.
We're going to have you
That's looking
reporting
down on the
right
deck.
up there through the launch to keep us plugged in behind the scenes. What are you looking forward to sharing with us today?
A lot. I'm really looking forward to making
1,
sure
2,
that
3,
you
4,
know what's
5,
going
6,
on
7,
in these
8.
rooms.
Nope,
take
don't know
you
what
some
that
of the
is.
personalities we've got inside, how it all works. You know, if there are a couple anomalies, we'll
Can
work
you
through
zoom
those
in on
together.
the
It's gonna be a
computer,
great time,
por
Ariane.
favor? Oh, it says
Love it.
pad
Thank
systems.
you
I was
so much,
wondering about that.
Maggie.
I wonder if that's the
We're
water
grateful
deluge
to
system
have
right
you up
there.
and keeping us
You
connected.
see all those
and of course, we're going to patch you in as
white
we go.
dots
Now,
around the
let's check
center?
in
It,
with
called,
our
it said pad
broader
systems.
Blue team.
I wonder if that's
Our
the water
employees
suppression
in Florida
system.
today are getting a close-up view of the launch over at nearby Cars Park. Eddie Seifert is there standing by. Eddie, you there?
Yeah, hey Ariane, welcome
Nice. Fairings reusable or proposed to be reusable? Proposed to be. So to my knowledge, they're definitely not doing any sort of fairing recovery attempts right now. But we did see them earlier this year work on that. So this is a picture of them working at Cape Canaveral Space Force Station on recovery of fairings. But to my knowledge, that's not going to be a part of this mission at all.
Is perfectly viewed in the distance, and we are.
I know, right? Enhance, zoom.
Park. We're joined by Space Coast residents. We're joined by family members, team members. This is really an exciting moment for Team Blue.
Eddie, now you're a familiar face across Blue Origin. You've got a front row seat at Blue watching this rocket go from design to build to test. What's going through your head right now?
You know, it's a collective sense of anticipation. Everyone here has done.
Oh, nice model, chat.
I
wonder if that's the one from the Blue Origin shop.
Family members have sacrificed for them to be here at this moment at New Glenn 1, and we have one proposal. Let's send it. Let's light this candle. Let's send New Glenn to space. Let's send Blue Ring on its mission. This team is hyped.
Hell yeah. I want to see something fly tonight.
Well, Eddie,
so remember, just as a recap, chat, this is the T0 currently. 18 minutes from now, we should hopefully see a launch, but there's a 3-hour window. So just because this might be the current T0, they actually have all the way until 2 a.m. Mountain Time, basically 3 hours from now, to actually launch. So we'll see. Hopefully it won't take necessarily that long, but we'll have to see how Blue conducts their actual countdown.
Of more than 10,000 employees that currently call Blue Origin home. And so that's what we're sending to space in addition to the hardware. And this team right here.
New Glenn, I know, right? Can't believe it's happening. Finally.
Well, thank you, Eddie. Can't wait to check in with you again shortly. You keep the Team Blue pumped down that, but I have a feeling you're not going to have too many troubles. No. They seem pretty psyched.
We're psyched to be
Rugs in Florida, yeah. What's the temperature there? I don't know. But it looks. Somebody said.
I look forward to what both.
I remember who was it? Was it you, Apollo, saying that it was a little chilly in Florida?
Let's take a little deeper dive.
Chilly in Florida means like 60, so.
So there is a lot. Right now, we are tracking a number of technical milestones between now and liftoff, and then there's going to be another set of critical in-flight milestones once we're underway. Now, we do want to be very clear.
So at Cape Canaveral, it's currently 51 degrees Fahrenheit or 11 degrees Celsius, so it's a little chilly.
For it. But
it's a little chilly.
Amount of ground testing or mission simulation is a replacement for flying this rocket in space.
Well put. Our key objective today is to.
So I already showed this graphic, but this is what they're targeting for their flight profile.
Icing on the cake, bonus points, cherries on Sundays, whatever you want to call it. We know that landing the booster on the first try offshore in the Atlantic is ambitious, but you can't win if you don't try, and we are going for it tonight. And no matter what
O-rings on New Glenn? Oh no, they have a lot of O-rings, many an O-ring, but not the same ones as
of course, in the design
Challenger.
Of the vehicle, but also into the operations. And about that booster, again, yes, we are going for it. New Shepard landed on only its second attempt in November of 2015. I happened to be on the ground for that in West Texas.
It's going to land here, chat.
And
it's going to land right there.
And man, I can't wait to see if we can make some more history.
It's going to land right where that great all is.
Our booster today.
It's going to land right here.
Been named with
it's going to land.
Cool
it's going to land, chat.
Want to tell us that?
Sure is. Our booster's named.
Oh, what a shot! Oh, I love this this camera angle.
Reference there for all you Jim Carrey fans. But let's level set here. You think we're going to stick the landing? Like if you were a betting lady in Las Vegas this evening?
I think they have a pretty good shot.
We think it's possible. You know, the truth is that this is an enormous goal. We're trying to land a giant building-sized vehicle that's plummeting down from space.
Building-sized vehicle, indeed.
So much complex engineering that goes into this. But you know, it's time that we try it for real, and today is that day.
Let's do it. Let's put it to work. We'll see how it performs.
It just keeps panning up, Chad. It just keeps going.
Learn a ton, get loads of data, and apply it to NG2 and beyond. Now,
so here you can see this is the forward module that I was talking about earlier. Oh man, come on, go back. Go back. So that's the forward module I was talking about earlier. We actually saw from Dave Limp, the Blue Origin CEO, they have a lot of RCS thrusters up there, and then also these fins at the top fully actuate. So this is what provides the attitude control going through entry.
There it is on the left side of your
And again,
screen.
this is the payload that they're testing. This is known as Dark Sky 1. This is their Blue Ring Pathfinder. So this thing is basically a big just hunk of aluminum that has a communication system, it has avionics on board, and it has a power system on board as well, all to test basically in-house built components that are going to be used on future missions for a what's known as an orbital transfer vehicle, or OTV. Basically, think of a larger version of this that has payloads attached to it that can separate from the upper stage and then go to another orbit.
Now, it's also worth noting
Make
that
the call,
today's
give it 20%.
payload
I'm going to call
is
60%.
non-separating. So it's going to actually stay attached to the second stage throughout the mission as it powers
Need
on
the
and it
opening
begins
scene
collecting
music of
data.
Spaceballs. Yeah.
For the broader system we're building, for the Blue Ring itself,
I'd like to think with how transparent they've been recently that they would show it. If it can be showed. I mean, you know, if it lands way off to the side and the camera just isn't there, then, you know, fair
around the
enough.
solar system. Today, on this mission, it's a super cool Pathfinder for that vehicle that will be flying. We have some exciting details to share a little later on.
It can fit 20 of them, Perry.
The exact technology that we're testing today, as well as Blue Ring. But I'll tell you right now, I'm
Inside that fairing, it can fit something like 20 Amazon delivery vans inside of it.
And the Blue Ring.
It's massive.
So
It's
much
huge.
work has come together today. And that's why today is such a big deal.
Oh, there you go. So here's the forward module I was talking about. You see those lines here? Those are the attitude control system. They're thrusters that fire to help orient the vehicle when it's coming in for reentry. Because remember, it's going to go up like this, but it has to land like this. So it's got to basically do a, you know, like 150-degree swing to start coming in engines first. And so these attitude control thrusters help it do that.
Perspective, the way I like to put it, data is the currency of success. The more
opportunity
data we have, the
missed,
better
yeah,
off we are.
100%.
The longer we fly, the more data we collect, the more we can crunch on, so we can.
Man, just look at that massive, massive arm, that massive hydraulic arm,
absolutely. And that data
both
is
attached
really
to the vehicle, and then also I believe this is potentially where it fills the propellant as well. Maybe it doesn't fill the propellants. The propellants are actually there, but yeah, they're basically big pincers.
And while we consider that system fully operational, that flight data that we get after every mission helps our engineers fine-tune the system. It helps us refine our procedures, reduces the overall
yeah, it's definitely important to know, right? Like, even if they don't land the vehicle, even if it doesn't make orbit, this is still at the very least a hopefully good test opportunity. But let's also not forget, this is supposed to also be the National Security Launch Contract certification flight, or NSSL certification flight. So, you know, Blue Origin kind of has a lot riding on this. So I think worst case scenario, it'll make orbit. All that will go well. It just might not land, which when it comes to everything, that is an amazing feat.
One that lands. Right? New Glenn.
A prediction has begun. All right.
Let's point out one big difference. New Shepard lands on a landing pad in the
static
desert,
landing pad.
While New Glenn's landing pad is out in the Atlantic Ocean. I should take a moment.
600 kilometers downrange.
The seas out there have been quite rough for the last several days. So, you know, that is why we took a little bit of extra time to get a.
You give that the
80%.
Yeah, fair enough.
This booster tonight. So, a big kudos to our team that is out there operating the Jacqueline.
Yeah, exactly, Aster.
They've been rocking and rolling, you know, with the waves out there for several days, but things are going to get exciting this evening. Now,
maybe, Perry.
Piece of this landing
I don't know about Interstellar. No.
The landing.
Not without gravity assists and whatnot.
We call the
not direct.
You want to tell us a little bit?
Because remember, New Glenn, although it's really, really big, I think it only has something like 6 metric tons to translunar injection, or something like that. Yeah, I think it's 45 metric tons to low Earth orbit, like 14 metric tons to geo transfer orbit, and like 6 metric tons to, oh, there's Jacqueline. That's the LPV-1 or Landing Platform Vessel 1 that's out in the middle of the Atlantic right now. But yeah, it's as big as it is, it's still, you know, I mean, it takes a lot of energy to get anywhere outside of Earth's sphere of influence.
Our first landing attempt for this rocket, we have got to make sure.
Oh, what a great shot. That's going to be so good to see.
Shot, a beautiful landing pad there with our Blue Origin feather.
You can kind of see some white caps there. It looks pretty good though. It doesn't look super rough just by what we can see here.
The vessel is going to transport the booster back to our facilities here at Rocket Park. We're going to do an inspection before flying again, and this is of course.
So this calls into question, like I was saying earlier, I wonder what kind of divert contingencies the first stage has, because there's a lot of infrastructure on this otherwise barge, right? Like they have both sides completely filled with what looks like some sort of infrastructure. Like you can see those structures there. Like we obviously wouldn't want New Glenn to hit those. So I wonder what kind of abort contingencies New Glenn has for that.
The Cape and the U.S., frankly, that are working hard to get us to our launch.
Hey, what's up, Prospector? How are you?
Let's take a moment and toss to New Glenn on the pad as we make our way towards the very first orbital flight for Blue Origin.
All right, we're within the 10-minute mark. Let's see what holds. So for now, chat, I'm going to stop that countdown since they have the count. Oh, it's T-minus 40 now, chat. Okay, so we recycled T-minus 40. So we got 40 minutes. Yep, count recycled. All right, that's okay. To be expected. Not surprised at all. I believe I saw Super Heavy get caught. Anything is possible. Yeah. I was saying earlier, right? Like the way Blue Origin operates, they are not SpaceX's like helter-skelter, like throw things at the wall. I mean, I'm being a little facetious here, right? But like SpaceX moves very, very fast, but they also do things, you know, really quickly and kind of just like, let's see what works, right? Blue Origin is very much a little bit on the older school side of aerospace mentality, where they do a lot of that stuff, but at the subscale. And then when they scale something up to the full system, they do what's called a proto-flight system. It's a prototype flight qualification system. So not is it just a full prototype like what we saw with the Starship systems. This is like their flight qualification system as well. So they're expecting this to work. So yeah, like I said,
back, everybody.
I have high hopes for them.
We are officially at T-minus 38 minutes and 57 seconds to go until launch, our first launch of New Glenn. I should note that as we go along here, you might see our clock bounce around a little bit. That's just our teams getting aligned and making sure that by the time we get down to zero, everybody's set and ready to go. But talking about ready to go, Denise, why don't you give us an update on the vehicle and its preparedness?
Absolutely.
Oh, nice.
So our team has already completed fueling up New Glenn's propellant tanks for both our first stage and our second stage. We are now entering the next step, which is called propellant conditioning. This is, of course, a crucial step because we need to make sure that those propellants are at the right temperatures and at the right pressures. We also need to manage pressure. You might have noticed
they call them
that there's
fins,
a lot of
Banyati.
gases that are being vented from our first stage and our second stage. This is because our cryogenic propellants are so cold that they're experiencing something called a boil-off. So we are venting all that excess gas to prevent buildup and overpressurization. You may have also noticed on your screen that we have the flame stacks, or what we lovingly call the tiki torches. That's there as a safety mechanism to make sure that we are burning all that flammable oxygen and hydrogen, protecting New Glenn and our launch pad. So that is where we are right now. We'll keep tracking progress.
Not oxygen. She meant liquid natural gas and liquid hydrogen.
Thank you very much. We will look forward to the next update on the team and the rocket there. Now, we mentioned that we're sitting in the rocket factory here. Blue Origin's mission control is right upstairs, right above our head.
Oh, interesting. They have the teleprompter even for this now.
Itself. So maybe if you zoom out a little bit, Denise, you can give us a sense from a geography-wise where we're sitting.
We are super close. So behind me, I have a map of Florida. You can see very clearly here we have Merritt Island and Cape Canaveral. If you go ahead and zoom in, I'll show you where we are right now. We are right now at Blue Origin's Rocket Park. This is where New Glenn is built, integrated, tested. This is where we're coming in live from our studio. And just a short 8 miles away,
Don't know yet, Captain Failure.
Where New Glenn is standing.
Haven't seen anything other than the only internal onboard cameras we've seen are from the payload fairing. So I'm not sure. So that's up here. So we will see payload fairing jettison, hopefully, if they have signal. But I haven't seen any other onboard cameras.
Launch tonight. So that's the lay of the land here. It just really goes to show you how the full operation of New Glenn is nearby.
And not only that, but New Glenn, the New Glenn operation is also right in the heart of all this great space history here in Florida.
So the Atlas II and Atlas
III. Oh, look at that. Atlas II and Atlas III.
Pioneer and even Surveyor missions.
This is what 36 used to be.
To explore Jupiter, Saturn, Mercury, and even the lunar surface.
They're doing pretty good for presentation, absolutely.
Renovated launch pad that carries all that history.
No, I think I speak on
what
behalf of
a
everybody
launch
here at
complex.
So
this is what I was saying earlier. This is LC-36. This used to be a 2-pad system. They used to have LC-36A and LC-36B. Blue Origin purchased the pads and turned it into one major launch complex for New Glenn. So yeah, that's pretty awesome.
Lights start shaking.
You know, from here, we can watch and hear just about any launch system that takes off from the Cape, and it gets loud. But we think this one, for New Glenn, may be one of the loudest ever. For one, the pad is just so close to Rocket Park, but also there's just the enormous size and power of those 7 first-stage BE-4 engines.
And we have been
3.8 million pounds of force coming out of the first stage. That's 17 meganewtons of thrust.
As a California girl who has lived through a couple of earthquakes, I am ready for this one. This is going to be awesome. Now, you mentioned a second ago, it's just so unique that the public is going to get such a great view of New Glenn launches, especially from viewpoints like...
So yeah, this is what we were talking about earlier. They're just going to go through and talk through some of the talking points. But yeah, this is what I showed earlier. If you are anywhere in the vicinity of the Space Coast, whether you're from basically South Carolina down to Miami, you're going to be able to see the rocket launch tonight, even all the way over, probably not Atlanta. Atlanta's a little bit farther up here. But if you're in Savannah or if you're in Marietta and all those sorts of places, even all over here in the Pensacola area, you should be able to see this rocket launch tonight, which is pretty awesome. Just look east or southeast. It should be pretty good. But the vehicle itself is, like I said, absolutely huge. What I wanted to show a little bit earlier when I was talking about it was we actually had some really, really good views of them doing the forward module testing. So we had this happen and this happen. Let's see if I can pull those up real quick. Where did we get those? Yes, here we go. So this is coming from Dave Limp on X. So this is what the forward thrusters actually look like from the forward module. So this is that big piece at the very, very top of the first stage that we see with the fins on it. These fins are also fully actuating. But this is what basically gives New Glenn its attitude control, because it goes up like this, forward facing, second stage separates and continues on, right? But then it's got to swing all the way around and do like a 150-degree maneuver to go engines first for its what they call the exo-atmospheric deceleration burn, or ECB. And then they get all of that prepared for landing. So this is, of course, the attitude control system, and we saw another great picture here, or video here, for from Dave Limp of them testing the actuation capabilities of these different fins. So this is what allows it to fly, chat. Very similar to New Shepard. New Shepard, right, has those fins both on the bottom and those static fins that deploy on the top. But this is what's going to guide it back down to Jacqueline. And then what we were talking about earlier as well, in terms of Jacqueline, there's a really cool video showing everything here as well. And this is another scene that we got from Blue Origin. about what Jacqueline is going to look like. We actually saw, this is the camera angle that we're going to have on board Jacqueline. Basically right here, they have like a GoPro attached to this railing. And we're going to be able to see basically from here outward to hopefully what's going to be a landed New Glenn first stage. So it's going to be pretty insane. It's going to be pretty insane. It's going to be a good show no matter what happens, hopefully. And then if you wanted to see the launch complex, I have another picture queued up here somewhere. There it is. Launch Complex 36. This is coming from Max Evans at NSF. But just look at this, chat. Would you just look at it? Just look at it, chat. So there's New Glenn. This was 36, Launch Complex 36A and B. You had, I think, B up here and A over here, and they basically took the entire complex and turned it into one gigantic one that also has room for testing. They did a second stage test, as well as a few engine tests here at the launch complex, which is pretty cool. So they have a lot of infrastructure developed. So here's a picture of what they did with the second stage. So they have a second stage firing test stand here at the launch complex. There you can see the lighthouse in the background. Notice that lighthouse there. And so if we go back up to that picture, you'll see that lighthouse right there. Boop. There it is. So yeah, they did an entire test stand somewhere around here for their second stage. It's pretty cool. They have a lot of infrastructure. This entire complex was like a $200-something million project, all for the New Glenn missions, which is going to be pretty cool. And then there was another thing I wanted to show, chat. So this is a cool little factoid, if anyone cares. Atlas LC36 failure. Believe it or not, LC36 was the spot of the largest Atlas failure on the pad. So that's pretty cool. This is what it looked like here. Let's see if we can't find a good shot. Nope, not that one. Was it this one that came back down? I don't think so. That was AC failure 1. Atlas, there was an Atlas Centaur failure that literally dropped onto the pad. I think it was this one. I think it was this one. I want to say it was this one. So yeah, if my memory serves in terms of history, I believe LC 36 had the largest Atlas Centaur failure on the pad, which is a little bit unfortunate. Let's see what happens. So I'll just let this play in the background. Google Maps Sat View is still showing Blue Origin hasn't built there yet, but Satellites Pro shows current build state of the location. Interesting. Nice. Nice. Yeah, it's funny how Google Maps is that far behind. So yeah, what we're seeing here is an Atlas Centaur on LC36, if I recall correctly. So here you can see the vernier engine, basically used for stabilization and a little bit of roll and attitude control. Everything looks absolutely great. Love to see it, chat. And then you know what you don't like to see? You don't like to see that. You really hate to see that, chat. That's not good. You see how it's flashing and it's pulsing? And then it looks like it's chugging. Actually, this is called chugging, by the way. Literally, that is the technical term. Chugging is when your combustion chamber has very high cycles of high pressure. So when you have high pressure in your combustion chamber, the fuel flow through the injector plate actually slows down. And so you get less fuel flow because of the higher chamber pressure. And so then that starts to reduce the combustion. And so the combustion pressure then goes down. And because it's now going down, your propellants in the injector head are now being thrust into the combustion chamber. And then that causes spontaneous ignition. And so then you have more combustion and higher combustion chamber. And this cycle just happens constantly at a really, really high rate. Because remember, this is in slow-mo. And now it's starting to fall. It's starting to fall. You hate to see it, chat. Just oof. Yeah, so completely ruined this pad, by the way, and actually is what I think pad B. I think this happened on LC36A, and pad B was in construction but canceled, and I think this failure, because it ruined the pad for a conceivable amount of time for refurbishment, NASA was like, yo, you know what? We should finish 36A, or vice versa, whichever one hadn't been finished yet. But yeah, so you just, everything looking great, and then just all of a sudden, that's not good. You hate to see it, chat. But yeah, thrust to weight ratio less than 1, 100%. But yeah, really interesting coming out of the history here, if I recall correctly. Anyways, let's see what's going on back at
the factory, and
because they're filling in time right now, chat. So I don't really feel bad about talking over this because they're just filling time. Because remember, we're already essentially 5 minutes past when they were supposed to launch, so they're just filling time at the moment. Is this like the ultimate form of Pogo, or just another name for that same thing? So Pogo's a little different. Pogo is more, at least in terms of my nomenclature, is more used for oscillations in this lateral oscillations of your entire rocket vehicle, where that is actual chugging. It's actual pressure inside of your engine that's changing at high cycles that cause fluctuations in your thrust output. So Pogo, I think, at least in my nomenclature, is different. Pogo is like literal, movement back and forth laterally. Have there been incidents where the pressure spiked so much it actually had the combustion products push into the fuel lines? I mean, I would think that that's basically a hard start. I would think that is basically a hard start. Right? Like if we've seen there's a good video of a hard start somewhere. Is it this one? I think it might be this one. Yeah, I think it's this one. Do they show it in slow-mo? I think they do. I hope they do. Maybe it isn't this one. Oh, there you go. Starts up and then pop. There's actually a really good one that happens. Well, this is a great shot. So this is what a hard start looks like. So you see all this right here? You can actually see the vapors at the very beginning. So this is like your fuel. This is like, if this was like a methalox engine, this would be your methane. Your methane is already outside of your nozzle, right? Because you're flowing methane in terms of the startup. And if you don't have your startup sequence dialed in, when you go to then run your liquid oxygen mixes, and then you can have spontaneous combustion happen outside of your combustion chamber. See how this is starting to turn orange? It's starting to turn orange. This is ignited. And if you've ever played around too long with, a spray can of some sort of flammable liquid, well, they say that it's a big danger because that can actually then go inside and pop the can. That's what happens here. So you get combustion outside of your combustion chamber, and then very, very quickly, it will go inside of your combustion chamber and ruin your nozzle. Well, ruin your entire rocket engine. Happens very, very quickly. So you just get all of that combustion byproduct just shoot back into your system, which is, yeah, not great, not good. There's another one that's like a really good one, and I just don't know. Was it? No, it's not Firefly, was it? I don't think it was Firefly. Rocket engine test failure. God, there's such a good video, and I just can't remember where it was. Maybe it was part of, I think it was definitely NASA. Rocket engine test stand. Yeah, I can't remember. If somebody can find the one I'm thinking of, it was a really brutal hard start that completely separated the entire rocket engine from the test stand. It was, I think, maybe it was the US Air Force. Somebody testing a advanced system that just unfortunately had a really, really bad hard start at the beginning. But anyways, let's get back to the live stream.
We have been working so hard to get to this point. All right. Well,
Wasn't Pogo longitudinal oscillations? If I recall, that problem was Saturn V that led to near breakup. The fuel flow through them interacted with the flexing of the thrust. Yeah, longitudinal, so like an accordion.
Here, and I have found a new place to hang out.
I was thinking it was lateral, but it might be longitudinal. Yeah.
Do you get to hang out
We're jumping on like a pogo stick. That makes sense.
Our audience gives you a sense of how close they are to just.
That was Astra. That was LV006.
Tell me about this view that you get and that some of our VIPs.
Yeah, they're still filling time, chat. We're still T-minus 21 minutes out.
On the balcony, we are on the 3rd floor of our
Did they
factory, and just
bring it back
out there,
again?
you can see
us at Blue.
23, 26? Nope. Okay, just making sure.
and then
Yo,
just
Iceman coming in with the raid. What's good, Iceman? How are you?
So you know when that
What were
rocket
you streaming
goes
tonight?
up, they'll be turning their heads briefly to the right. So
Astra
we're out
was
here, we've got
TWR
some
equals
guests,
1.
VIPs,
Glorious. Yeah, 100%.
Blue family inside. They're still in there while it's warm, but I expect to see more and more people headed out here soon.
Now, Maggie, I know you're able to also listen in on the radio with the team behind you. What are some of the things that you're hearing?
Sure. About this time in the count, I am hearing them going into their weather brief. They are making sure that everything
Once
is
human,
down
awesome.
range.
Very
That's
good.
why
How you
the
doing,
water
Iceman?
band
Hope you're
is
doing swell.
there, and I haven't heard
We
anything
are
thus
gearing
far.
up for hopefully what's shaping up to be a solid launch tonight.
Thank you, Maggie. So great to have you up there, keeping us tuned into all of the action. As we noted, we've got launch control and mission control right back to back. We'll be checking in again with you in a couple of minutes.
It's a free game.
Okay,
Oh, yeah.
we're at T-minus 19 minutes and 50 seconds to go.
Nice.
Our
So yeah, this is what I was talking about earlier. See that big structure in the background? That's that forward module that has the fins and the thrusters on
I
it.
want to point out a few things coming up ahead in our countdown because some of them actually come in a pretty quick
Sweet.
sequence.
Yeah, so coming up, we're going to have a planned weather check. This is where our teams take one last look at the weather for launch today.
Cool.
This weather check validates that our
Go, no go,
test is
chat.
still on track.
Range is green.
We'll continue to close out any remaining open items that could be on their dashboard.
The very capable folks in launch control upstairs will undoubtedly be checking through closeouts over the next few minutes or so. And once we get through those, we'll start to go into some final vehicle checks. So you want to walk us through those final vehicle checks?
Once we get to about T-4 terminal count, we're going to transition New Glenn into where our auto sequence begins.
Lots
and
of grass,
the operation
yeah.
really becomes hands-off for our operators. We're going to be switching New Glenn to internal power, internal hydraulics, and things will move really quickly from there.
And then, as we approach the final moments, and just before we light the engines, there's this water deluge.
It's a huge water deluge. This is going to engulf the flame trench completely, which is going to protect our rocket from vibroacoustic and thermal loading. Finally, autopilot will be enabled. We'll flex the gimbaling engines. And
Sweet.
then
Oh, I want to see the gimbal.
Game on.
I want to see the engine
Ignition.
wiggle, chat.
I cannot wait for that moment. So all of this is very exciting, even to just hear said out loud. I think there's also a very specific sequence for starting the first stage engines. And talk us through that, because it's not like they just all turn on at once. We got to be careful about how we sequence the engines igniting.
correct. So
Oh,
you might
look at
think
that.
we ignite all
Yeah, you can
7
see the
vehicles at once.
propellant
That's
lines
actually
here.
Not the case. We do something called a staggered
You can
start
see
sequence. Engines 1, 4,
basically
and
the pincer
7
arms that
light
help
burst,
hold the
followed
top of the
by
rocket to the
engines
strong back.
2, 3, 5, and 6. Now, of course, these will happen in a very
Yep, this
quick
is from
succession,
LC36
but
at the Cape.
staggering start really helps to decrease the sudden pressure on the whole system. There just truly is so much power in those BE4 engines. So staggering them creates a more smooth on-ramp for all that power.
Absolutely. And we talk a lot about the rocket, but you can't forget the ground systems as well, right? So when we are essentially protecting the rocket from the vibration and all that power coming out of the engine, we're also protecting the launch pad itself, right? You see from the map that you showed us earlier how close we are to the water. The water table is just a couple of feet.
Elon, wish Bio good luck. Awesome.
Pad. And I should really talk. A
I would hope
lot
so.
of engineering went into the complete refurbishment of our launch complex, and so we want to take care of it. It's there for the long haul. But man, we got a big old powerful rocket. So this water deluge system is critical to both the rocket and the ground.
And that water deluge system that they're talking about is all filled
We are at
or supplied by this massive water tower.
Clock update here. We are at T-minus 37 minutes.
That massive water tower.
Seconds to go until launch.
Gravity
as we mentioned,
feeds the water deluge system.
Kind of what we can expect from our team as they get aligned and ready to go.
Yep, recycled again, chat. Like I said, we have a 3-hour window here.
You know, we say this on the New Shepard webcast as well, which is we have spent years designing this rocket and, you know, months building it and months going into designing this operation. If we need a couple more minutes before we, you know,
it's okay.
press go,
it's okay. This is not to be unexpected, chat.
So with that, why don't we take a moment here to check out this beautiful New Glenn rocket on the pad, getting ready for its first mission to space ever.
Oh yeah, you can see all the attitude control thrusters up here. Nice. Yeah, so really not to be expected, chat. This is their first flight. They're wanting to make sure everything is go. Remember, this is them doing it for the first time for real. They have done, of course, wet dress rehearsals. We've seen some fantastic videos coming from Blue Origin in terms of some of the flight or the static fire testing that they've done. I have that queued up here somewhere, New Glenn static fire. So yeah, we have a lot of good stuff here that's been, you know, in the works in the background. But again, this is a new rocket. This is the first time they're running through it for real, so they want to make sure every I is dotted, every T is crossed. Because otherwise, if it's, you know, not going to look good, well, then it's better to just scrub. But hopefully that doesn't happen, chat. Knock on wood, we have, like I said, 3 hours. We have 3 hours for this launch to actually be able to take hold. So we'll see. We'll see what has to happen, chat. We'll see what has to happen. But I still have high hopes. But yeah, doing postpones in the count and stuff like that, recycles, totally not unheard of, especially for a new rocket. Hey, what's up, Blurgert? How are you? I know the industry looks to compete, but also wants the competition to work, but it's still nice to see the well wishes. Oh yeah, of course. Yep, 100%. It's definitely good to wish your competitors good luck. What is that saying? Competimates. You're all competimates in the aerospace industry. Space is hard. You never know when you need a favor or something like that, or when you actually want to collaborate on something. Who knows? Like in some odd twist of fate, right? The SpaceX could need New Glenn to launch Starlink. I mean, I don't know, right? But we do know that Amazon has already contracted Falcon 9 to launch their Kuiper program. Of course, Amazon is not Blue Origin, but there is, of course, some history there. But yeah, you just never know. You never know what's going to be up. How many opportunities can you get for a first impression? Yeah, I mean, many, I guess. Question mark. There's plenty of rocketry market share to go around. Yeah, it's only scaling. Remember, Bank of America and another prominent market valuation company both say that the aerospace industry is supposed to hit $1 trillion by 2030. The aerospace industry is supposed to be at I keep saying airspace, technically only space. The space flight market is supposed to hit $1 trillion in market value by 2030, which is wild. You know how much of that is launch right now? I think launch is only like 10 billion. 10 billion, and it's supposed to grow to, I'm not saying launch is supposed to grow to 1 trillion. A lot of that is like global communication satellites like Viasat and Intelsat and Starlink and Kuiper and all those different ones That's where a mass majority of the revenue or market share is coming from. But yeah, even launches are scaling pretty quickly. Probably not as fast as some hope, or we're hoping, like, right? Because we had Relativity recently coming out with troubles because they're trying to scale into a larger rocket to bypass all the small launch providers because they see more prominence in the larger rocket vehicles. You know, there's a whole bunch of stuff. We've seen several prominent launch providers go belly up and bankrupt and having to do a whole bunch of different things just to stay alive, like Astra. So yeah, we'll see. We'll see what the future holds, right? You overslept your alarm. What's up, Graham? So we are now 19 minutes past the original T-0 time. They have recycled the count twice. Totally normal. Everything is fine. They're just running through their checks and making sure that they have plenty of time. They do have plenty of time. This is a 3-hour launch window and we're not even 20 minutes in. We just passed the 20-minute mark. So yeah, plenty of time for them to launch this thing still within their flight window. So we'll see.
Top and go again. But again,
James Webb was only 10 billion, but it's 1% of the way to a trillion. Yeah, exactly.
Today, the primary objective is to go to space, go to orbit safely.
A 3-hour tour, some could say.
And if
some might say.
Land this booster, as we mentioned before, there are going to be a lot of people losing their minds, mine as well. So stay tuned for that.
This KSP install looks amazing. Yeah, I know. I got a new computer and all that.
So the Blue Ring team is up in mission control right now, also surely tracking their own checklist as they make sure the Pathfinder payload is ready to go to launch as well.
Correct, yeah. So upstairs at the MC, we'll have a launch control and mission control. So our launch team is the one that's doing all these systems.
So they're doing the system functional checks at the moment.
Sure that they're doing similar system checks for the Blue Ring Pathfinder.
Wonderful. And let's take a second and dig in a little bit more.
Nice. Look at that mission control chat. Wow.
The Pathfinder is a cool piece of technology, and really, it's just the initial demo for a vehicle program called Blue Ring. That's quite far along in its own development. And we mentioned this earlier, today's demo is a non-separating payload. This means
plenty of RGB,
yeah. Is going to stay attached to New Glen's second stage for the entire 6-hour mission. The other thing I want to reiterate about this Blue Ring Pathfinder is it's going to be testing a lot of the same technology, but it's not the Blue Ring itself. It's not the same form factor, but we're going to learn a lot from this evening. Now, what we want to...
I would consider that still spaceflight Aqualets.
As we talk about the Blue Ring Pathfinder,
or launch providers, which is in the space category,
that it's attached to the second stage, and it will stay there as it orbits the Earth. And
okay, we've been through all that. I'll recap all this here again as well. But what's the difference between launch windows? Starship has a 30-minute launch window usually. Why is it so short if New Glenn can have 3 hours? Because of what SpaceX has as their landing zone. Pretty much that's the reason why, right? They have a designated corridor that they have to hit in terms of their trajectory for Starship to land off the coast of Australia and the Indian Ocean. So they have a very specific window that they have to launch to be able to hit that re-entry corridor, because per FAA regulation rules, your system has to have a controlled re-entry point. So you have to know where it's going to land. You don't want it to land in the middle of Sydney, Australia, for example, right? Where there could be people hitting stuff. So that's why Starship has a very specific flight window. New Glenn, though, is going on a very, very highly elliptical mission. This is going to be the future of the payload that they're launching tonight. They're launching a prototype of this vehicle, and it's really a rough prototype. It's mainly just a aluminum structure that's testing their communication system, their power system, and then also their avionics system. But it's going to eventually be a system that can ferry payloads to different orbits, separate from the upper stage and all of that. But not tonight. Not tonight. The prototype is going to stay with the upper stage. That's what she was talking about, all the way through the 6-hour flight. So it sounds like they're basically going to do a once orbit, because this vehicle is going into a 2,300 kilometer by a 19,000 kilometer highly elliptical orbit. And so it's a 6-hour mission overall. But this is going to be the future of what they're calling the Blue Ring Pathfinder that they're launching tonight. Blue Ring in and of itself is supposed to be what's known in the industry as an orbital transfer vehicle, or OTV. And like I said, it's pretty much just a small propulsion and power module that you can fit a whole bunch of other payloads on, and then it goes and ferries all of these different payloads to different orbits. Because one of the problems with having a very large launch vehicle, when you can launch a lot of small things on it, is all like, let's say 100 different satellites all get dumped in the same orbit. But that isn't usually good for a lot of different missions, right? You actually want your satellite to go into a specific orbit. And so because your upper stage just dumps you into the same orbit as everyone else, sometimes you want to hire a provider to take your vehicle from that parking orbit to another destination. Whether you need it to go higher or lower or into a different inclination. So that's what Blue Ring is designed to do. It's known as a last mile delivery service. Because you basically go from one particular orbit that the launch vehicle puts you in to a dedicated orbit that your mission is actually supposed to go to. So yeah, really, really cool that Blue Origin is looking to provide that basically right off the rip here. Yeah, what Tom Mueller's company is designed to do. If you guys know Tom Mueller, he left SpaceX as like their chief engineer for propulsion. He's the one that developed like Merlin 1 through, all of the Merlin engines and whatnot. He left to go start up his own company called Impulse. So Impulse Space is doing the same service. They basically build a propulsion system that's designed to basically carry a whole bunch of other smaller satellites on it, and it ferries those satellites to their intended target orbit. But yeah, so that's really cool. That's what they're testing tonight. I showed this a little bit earlier, but this is what the payload actually looks like. So you have this massive 7-meter wide fairing, 23 feet in diameter, for this little guy right here. Like I said, it's basically just a big aluminum milled cylinder that has a communications system on it. It has avionics on board, and it has a power system on board as well for this, what will be apparently a 6-hour flight for it. So yeah, pretty cool. Yeah. That's where we are right now, Chad. Hope we got all caught up with what they were saying.
Hawaii, the state of Georgia, and even Australia.
Yeah, these ground stations will collect telemetry and radiometric data, which is crucial for understanding how the spacecraft is performing and navigating in highly elliptical orbits in the MEO range. Now, this is unique because it allows the spacecraft to spend a significant amount of time over specific areas of Earth, making it an ideal orbit for certain communication and observation missions. And this is all part of proving how Blue Ring
basically they're sending a walkie-talkie into space, all to improve what's known as the TRL, or technology readiness level, of their assets,
which undoubtedly will play a vital role in further space exploration and communication technologies.
That data and experience
30 degrees
gained from
inclined,
this Pathfinder
Bonnietti.
mission will be invaluable for our engineering team. It really does pave the way for more advanced missions. It helps ensure the reliability and the efficiency of future Blue Ring vehicles.
There you have it, folks.
That's what I just said.
Now,
maturity.
Blue Ring Pathfinder
Mature the technology.
is supported by the Department of Defense's Innovation Unit, or DIU. And let me tell you, we're so thankful for their involvement today.
Nice.
I should say they have been...
So DIU is basically I think they're a private funding vehicle that's like basically sponsored by the military or something like that, or they work very closely with the military. And I think last year, or maybe it was 2023, they had a lot of investment into different space technologies for what's known as orbital transfer vehicles, or OTVs. And so I didn't know that. I just learned that apparently Blue Origin was a recipient of one of those contracts.
For the launch. This is our first flight, and we've prepared rigorously for it.
Getting frosty, chat, super frosty. Look at all that ice coverage.
And our key objective today is to reach orbit safely.
Proposed ground track, I'm not sure.
Is icing on the cake, bonus points. We know that landing the booster on the first try offshore
The wing
is
strike here looks like the space shuttle leading edge.
no matter what
I wonder if
happens
it's
today, we're going to learn, refine, and
RCC,
apply
reinforced
that
carbon
knowledge
composite,
to our next launch.
which is what the space shuttle
We're really
used.
looking forward to seeing how the vehicle performs. As I said earlier, more data, the better, right? We've pushed every single part, component, system in our testing well beyond its limits by design. But we
Giant
also
space
recognize
plushies.
that no amount of ground testing or mission simulations can replace the real-world conditions of flying this system into space, which is why we can't wait for the mission to get underway, see how things perform, and apply all the lessons learned to our next launch and beyond. It is an absolutely thrilling day. Again, we're so glad that you're here to share it with us. Now with that, we're at T-minus 22 minutes.
There you go. There's your foam.
And 30 seconds to
There's
go.
this concept to have a foam debris catcher, basically sending out these long, expandable foam spider webs to capture debris. There you go. That's being worked on. That's cool. Is that the reflection of the tower in the background, the flare for getting rid of natural gas boil off? It looks mildly concerning in this shot, but I'm pretty sure it's just a reflection from this over here. All right, 21 minutes, chat. The orbits need some vacuuming, yeah. Wouldn't a laser broom be more effective? I don't know. There you can see the downcomer. At least I think that's what that is, right? Or is that just the raceway? New Glenn has an external downcomer, doesn't it? Or maybe it doesn't, because it's only liquid natural gas and liquid oxygen. I'm not sure. Does anybody know? Is that a downcomer for the liquid oxygen, or is that... Well, it is venting right there, so I guess it is. That's cool.
Again, everybody, for joining us. We are at T-minus 20.
It's a raceway? They have a vent
go
there, which is
until
interesting.
New Glen's first launch. What a day for us. And,
Not sure.
you know, it takes many, many smart people to bring a vehicle like New Glenn together. And one of those great people that I've had the pleasure of working with over several years is someone who now leads up customer integration for New Glenn. That is Blue Origin's Laura McGinnis. Laura is the Vice President of Mission Management for New Glenn. Now, before Blue, Laura spent time in a similar role with United Launch Alliance. She also had quite the career at the Air Force. And I had the pleasure of chatting with her just for a few minutes, just a little bit earlier, to hear what customers can start to expect from a vehicle like New Glenn. Let's listen to that chat.
Laura, thank you for taking the time, especially on such an important day, to give us a tour of the factory. This is kind of like your second home, I imagine, for the last couple of weeks.
Absolutely, Ariana. We're so excited about this factory and super excited to show you all a little bit about it.
Well, so talk to me a little bit about what we got going on here. We've got
It's a massive
multiple rockets
factory,
coming
chat.
down the line.
Yeah,
This is a
all kinds of
massive
things going on.
factory.
So the basic layout is that the raw materials comes in from the south side of
Remember, each one of these is 7 meters in diameter.
we
It's a two-story
weld the
tall
tanks
building
together down
wide.
there. Then we bring the completed modules here for assembly. Over here we have our GS1 aft module, which will have landing legs, 7 BE4 engines installed. We do all of that work. We continue to assemble the stages down here. We build fairings. Behind the wall over here, our 7-meter fairing, which our customers love, and eventually we roll out the Glenn Stage 1, Glenn Stage 2, and the fairings out of the north end of the building. Those are all transported 8 miles over to Cape Canaveral Space Force Station and are assembled in our integration facility over there prior to launch.
And that's also, of course, where we integrate the payload as well. Just talking about customers a little bit, what have
Your
the
alarm
various
clock went
customers
off
been
33
saying
minutes
about
ago
what
for
they're
this.
excited about?
I hope
We're
they like
working
this
with our
candle. Me
national
too.
security customer right
Welcome to
now
the stream.
on certifying New Glenn
Me
because
too.
they really need an additional launch system.
Right.
We're also working with our NASA customers. They've got a lot of interest in the size of our payload fairing, both for rideshare kinds of things as well as large telescopes and
Gosh, it is such a
instruments.
pretty rocket, though,
Commercial
gotta say.
customers are thrilled about our capability of bringing many small spacecraft.
This
to
is the
LEO.
parts of the
We've
factory
already
they
been
let
doing
us see.
some
That's true.
Integration precisely with these customers. How has that process been going with our customers?
Yep,
We know our
recycled again.
customers make us
Son of a.
better. So these customers, many of them have been launching different missions, different
By how
systems for
much?
years and years, and working with them to understand their needs, understand how we can adapt
Is it
our
10
system
minutes?
to
They
best
recycled
meet
again,
their
13
needs.
minutes.
So
Dang it.
that's kind of the longer term work that you and your team have been doing. But let's get back to NG1 for a second. What have the last couple of weeks been like down here at the Cape?
It's not simple to take this whole system into a successful vehicle. I would say one of our best learning opportunities was our integrated launch vehicle, Hotfire.
Video was
It was awesome.
beautiful. Was also wing blue.
Oh, there's the static fire that we saw
Game time.
earlier
Yep.
this past week.
This launch, NG1, what are you most looking forward to? When it is go time, when the rocket lifts off,
Yeah,
what do you
maybe,
think that's gonna
maybe.
feel like?
I mean, I will say
Might be a good time to take a
I love that
quick
final
nap.
4 minutes when we pick
Quick
up terminal
nap chat.
count and we're counting down and the room is super quiet, the energy, the excitement, the moment, and then feeling that lift off, seeing it on its way over the horizon, and then hearing that final call out that we have inserted our payload customer successfully into orbit is like just an amazing moment, and I can't wait for it. I know New Glenn's going to do it. It's going to be a great day.
Hell yeah. All right, Engelman. Yep, have a good day.
A big thank you to Laura again for joining for that quick tour through our factory right behind where we are this evening.
Oh, it's a beast, chat. It is a beast. See if I can't half this. Can I? Can I half this? Oh, it's gonna do something weird. Oh no, it'll work. Perfect. Do something like this. We can kind of fill the dead air time that we have. We can keep the live stream going while we basically fill the dead air ourselves, as we have at least 31 minutes to go over, chat.
Okay, we are at T-minus 31 minutes and 6 seconds to go until NG1. We continue to tick down towards our first launch. I will mention again, you know, you may have seen we went down and then we
My
added some more
girlfriend
time to
looks
the
at
clock.
me and says, "Why are
That
you
is
doing this?
just
Getting up
fine.
at
That
6
is our
a.m."
team taking a couple
Yep.
more minutes to make sure that all of their procedures are aligned.
You got the space
as we
bug,
tick
that's all.
down towards
That's what it is,
T-minus
it's dangerous.
0. So you might see a little bit more of that happening here. While we've got a little bit more time, why don't we talk about the flight profile for this evening's launch?
Ooh,
What is
I got that.
going to
I got
look
that, chat.
like
Flight
as we
profile
see
right
this
here.
vehicle fly today?
There you go. Flight
You know,
profile.
we've imagined New Glenn's flight for so long. We've looked forward to this day, and I'm so excited just to see another
Got it queued up.
vehicle
I'm ready
of
for it,
this
chat.
size flying
Looking
over
like a
coastal
scrub?
Florida.
No, they have
We're gonna be
3
feeling the
hours
power of those
of a
B4
flight
engines.
window. Yeah, they have 3 hours within this launch window. So we're not even, we just passed 37 minutes from their original T0. It's not unheard of to push back a launch site, especially when, or push back a T-0 launch time when you have such a large window. Vulcan did this, right? I think it was Vulcan that did this, right? You know, Artemis did this several times, if I recall correctly. Just new rockets, you know, do it. When you have the time, why rush? Make sure everything is right before going. But yeah, ooh, very nice. We actually have some animated pictures here. Let's do it. The actual flight profile.
As the rocket ascends, it will encounter maximum aerodynamic pressure,
Max
known as
Q.
Max Q, at around 40,000 feet or 12 kilometers. This is the point at which the stress on the vehicle is at its highest.
Yeah, they have
3 minutes
another
into
2.5
the flight,
hours.
The vehicle will turn off its engines, marking the end of the boost phase.
So Miko happens at around 100
Shortly after,
kilometers,
the reusable
105
first stage will
kilometers,
separate and begin its journey back to
based on
Earth.
that graphic, roughly.
2 BE-3U engines on the second stage will ignite and propel it onward into orbit with the payload.
Nice.
The reusable booster reorients in the vacuum of space using its reaction control system.
We showed that earlier.
At 220,000 feet or 67 kilometers, it executes an exo-atmospheric deceleration burn using its
Supersonic
Center 3
retropropulsion.
engines. These engines gimbal for maximum control of the booster. This burn slows the vehicle down before
God, I hope
re-entering
we
the
have this
atmosphere.
camera angle. I hope we have
As
this
it
camera
descends,
angle,
the
chat.
booster's strakes and fins work together to slow it down and guide it autonomously back to Earth, landing on a vessel at sea. At around 9,000 feet, or just under 3,000 meters,
Me too, Angle.
the first stage begins its final landing burn. The 3 middle engines will
They
light
probably
for 20
will,
seconds,
Benjamin.
slowing the vehicle in preparation for the final descent. The 2 outer engines will turn off, and the center engine will execute the final controlled maneuver onto the landing platform.
Just like that. It's going to be just like that.
The vessel will return to Cape Canaveral to prepare for
Oh, they
its
have the
next
ROV,
mission.
or remote,
Meanwhile,
remotely
in
operated
space,
vehicle.
The second stage will continue to power the payload towards its final orbit. At around 400,000 feet, or 120 kilometers, the payload fairings will jettison. New Glenn will deliver an unprecedented range of payloads. Large satellites, dual payloads,
Hell yeah.
orbital vehicles, large constellation dispensers, even moonlanders destined to establish permanent human presence on the moon.
First try. That's right. Nailed
This
it.
is New Glenn. This is how we will build a road to space.
Nice. Nice. God, I can't wait for that. I hope that hits it on the mark tonight, chat. And as they they've been waiting and monitoring the sea wave, that's why it's always getting pushed back. Yeah, it's been pushed back since earlier this week. Its original flight, I think, was supposed to be like Wednesday of last week. They've been pushing it and postponing it up until now, because the weather out in the Atlantic, where the LVP-1, or Landing Platform Vessel 1, known as Jacqueline, has been stationed out here. And when I mean stationed out here, it's like 620 kilometers downrange. It's over 300 miles offshore, waiting for the first stage to land. So, out there in the middle of the Atlantic Ocean, it has been very rough this past week. And so New Glenn, to make sure everything has the best possible chance, has been pushing it back and back until now. So hopefully we'll see a launch here in 26 minutes. Up there is the timer, just passing the 26-minute mark. But yeah, this vehicle is an absolute beast. In terms of its overall capability, chat, the overall height of the rocket is over 32 stories tall. It's 98 meters, or 322 feet tall. Its diameter, it is 2 stories wide. So it's 23 feet wide, or 7 meters in diameter. Payload to orbit is an astounding 45 metric tons. To put that into perspective, Vulcan, the new ULA vehicle, Vulcan, can only get around 26 metric tons into low Earth orbit. And then Falcon Heavy, of course, can only get 22 metric tons into low Earth orbit. Now, that is not Falcon Heavy's actual capability, but it is the capability that it is rated for. Because Falcon 9 has a payload attachment fitting that is standardized across all Falcon 9 vehicles, and that thing is only rated for like 22 metric tons. Unless they've changed that, especially with the extra large fairing that we have recently seen at the Cape. So this thing will be the most capable launch vehicle aside from Artemis that will be operational, since technically speaking, Starship isn't operational yet in terms of any payload. So we'll see. Hopefully that will be good for them. The expected cost for New Glenn is $68 million, which, if that's anywhere remotely true, that is going to be wild, because that is 45 metric tons at $68 million. To put that into perspective, Falcon 9, which can only get around 16 metric tons into low Earth orbit, is around like $58 million, so like $10 million lower. So that is a brilliant price tag if that actually sticks. Now, these are old numbers. These are just projected, probably not going to actually be the cost, at least not for a while, until they can really start pumping out New Glens, maybe in 2026. Because I think Blue Origin wants to hit 25 flights of New Glenn, right, in like the upcoming year or two. So that's going to be pretty capable. That's going to be pretty crazy. And then, of course, partial reusability. First stage is designed to land at the landing platform vessel, Jacqueline, that I showed off earlier. And then, of course, the fairings are supposed to be reusable, but that is a future implementation. So fairings, to my knowledge, will not be looking to be caught or fish out of the water here tonight. Now, in terms of the first stage, we have a whopping 7 BE4 engines, each one producing around 2,400 kilonewtons. That's each one putting out like 550,000 pounds force. Technically speaking, the BE4 engine, if my memory serves, is more powerful than the Raptor 2, just by the actual power numbers. But also keep in mind, like I mentioned earlier, Raptor 2 is like half the size. So put that into perspective. Also, the actual propellant used on the first stage with the BE4 is liquid natural gas and liquid oxygen. Compare that here to the second stage. We have 23 meters in total height. That's 77 feet, almost 8 stories tall. 7 meters diameter as well. 7 meters across the whole vehicle in terms of diameter. We have 2 BE3U engines, each one producing around 700 to 750 kilonewtons apiece. That's on the order of like 150,000 pound force. Total producing 326,000 pound force of thrust from the upper stage. And the upper stage is actually using liquid hydrogen and liquid oxygen, so not the same as the first stage. So that's pretty cool. If you were looking for pictures of, obviously we have seen the first stage, but here's the picture of the second stage, the business end. This is what the BE3U upper stage engines look like. The upper stage does have 2 of them, as I mentioned. This vehicle is absolutely super, super large. And right there is the recovery ship, chat. Right there is hopefully where we can see the landing of the first stage occur, right where that great all is, right there in the middle of the feather that is Blue Origin's, what would you call that, logo? Yeah, should be pretty good, chat. Should be pretty good all in total. What are they saying? Any updates? Nope, just looking at the fantastic back shot of New Glenn on the pad. Hullchem VDS would be pretty sick. Absolutely. You think the payload fairing volume is bigger than your apartment? Well, let me put it into perspective for you. It's on the it can fit on the order of 20 Amazon delivery trucks in it. You know those like electric vans that we see around? It can fit 20 of those in the fairing. Yeah. Big. It's pretty large. Yeah. I have no idea what that breaks down into, like, square footage, but yeah, it's big. An entire New Shepard can fit inside of that fairing. Yeah, I have more graphics for you, chat, if you want them. Goes up here. This one right here. See? An entire New Shepard can fit inside New Glenn's fairing. New Glenn 7-meter fairing is 16,000 cubic feet in volume. So, there you go. An entire New Shepard vehicle. There's also another graphic that they had at some point here as well. Yeah, this is what I was getting that other metric. More than 20 moving trucks at the standard 16 feet moving truck. 800 cubic feet capacity can fit inside the fairing. Yeah. What is the maximum payload to orbit? 45,000 kilograms. 45 metric tons. Yeah. What is that in pounds, you may ask? If for those of us not on the, yeah, 99,000 pounds. To LEO. Ooh, chat. Oh, we haven't seen this yet. Yes. Look at that. It looks like we have IR footage of the engine section. This is the aft module of Blue Origin. This is the 7 massive BE4 engines that we were just looking at. That's awesome. How much of this rocket is the fairing? What do you mean how much? If you're talking about in terms of like the picture, from that, those holes right there, if you can see that, see these holes? That's the vent for the fairing. So this, basically where that line is, up. Oh, percentage? I don't know. I don't know, somewhere on the order of 25%? Question mark? It's hard to see in the scale here. What is the total height of the rocket? Total height of the rocket is 98 meters, so 57 and 23. So we can do that calculation, right? 98 minus 57 minus 23. It's going to be 18. So 98, so 18 divided by 98. 18%, there you go. 18%. A little bit more than 18%. So yeah, how tall is that fairing we just looked at? 0.18 times 98. It's a 17 and a half meter tall fairing. That's pretty crazy. We're finally below the 20-minute mark, chat. We haven't been below the 20-minute mark, it seems like, since the first bout. And they've done 2 recycles, right? So, knock on wood.
Welcome back, everybody. We're at T-minus 16 minutes and 45 seconds to go until launch here. An exciting evening for all of us here at Blue Origin. I'm so glad that you've joined us. Now, we have spoken about the wealth of experience in the New Glenn launch and mission control rooms upstairs, and I want to take it back.
Yeah, I know, right, Dad?
To Maggie upstairs.
Yep, recycle.
Who is standing by up there. Maggie, you with us?
Yep, Ariane, I am back at mission control, and as we make our way towards terminal count, the energy is high. It might seem like it's a little quiet with everyone sitting down, but the communications are ongoing. The launch director and his team are working super hard to get us there.
I love it. They're in the zone. So, Maggie, I'd love for you to talk us through some of the people behind the mission up there. Walk us through who's on console.
We've got some of our best and brightest here in the Mission Control Center. So the Mission Control Center is actually
he changed. The pad system guy changed his UI
engineering support room
from what it was earlier.
Our team is looking through data.
So there's Jacqueline. All right, one second. So there's Jacqueline. That's the ship that's out in the middle of the Atlantic. Oh no, go back to the full screen. Full screen her. All right, let's see. We have Ben Dijkstra as LD.
Ben actually comes from our New Shepard rocket. So Ben is a great example of how we take our flight pedigree from New Shepard and we are building it into New Glenn. Now Ben and I go way back.
I leave personal sticky notes for my counterparts on other ships and perform a ritualistic fist bump before terminal count.
And I was asking him what his pre-launch traditions are and what he's bringing here to New Glenn. And he gave me a couple answers. One, he sets 3 alarms because he really does not want to miss his call. I have a feeling he didn't have to actually use all 3 of them today, but I'll ask him afterwards. And then he also sets little Post-it notes on the screens of his console mates so that they get a little funny note.
Hey, what's up, Ben?
A little encouraging thing from their launch director before they
You're
go.
awesome. Hell yeah.
And when we do terminal count, he will be doing his fist bumps with the entire team.
Sweet.
I love it. I know Ben is going to crush it. Why don't you give us some other highlights? Who else is supporting Ben with launch control today?
Ben run us through it. Supported by a really large team, and we're not going to have time to touch on them all, but a couple here. First, we have Ann Dickey. Ann is the assistant flight director, and shout out to New Shepard again. Ann comes from that program as well. Now, Ann has been working the integrated schedule.
Do you also have Ann in chat?
All week long, really making sure that this team is ready to go. And after we launch successfully, she is going to get herself an ice cream cone, and I will be joining her. next we have Martin De La Torre.
Where are you going to get an
Martin
ice cream
is
cone
a ground
at
controller, which means
like
that he will be
3 in the morning
working through
Eastern time?
all of the data and controls of our ground system out there at the pad.
Martin.
So, as complicated as we all know rockets can be, the systems that are working around it are equally as complicated. And so Martin has a tough job today. But we know he's working
for
hard.
ground control, all the pad systems and stuff.
His favorite quote is from Stephen Hawking.
Ground control, in my opinion, is one of the hardest things in terms of launch vehicles because, God, it's just so many disparate systems, and all of them are feeding the rocket and getting telemetry and have their own telemetry. Ground systems are tough.
And Stephen Shelley is our offshore
McDonald's
recovery lead.
doesn't McDonald's
so
close
as we
it too?
go through this whole
now?
process, the team and the launch director Ben are constantly
Offshore
checking
recovery.
in with Stephen to make sure that we know that the barge is ready should we be able to land New Glenn. His launch day ritual is actually the same as Ben, another 3-alarm guy. So we'll be asking him as well. And
Hey, thanks, Botch. I'm glad you're enjoying it, man. Yep, I always try to make sure I am
Maiden is
prepared.
one of our 2 primary launch controllers, which means that she has control authority over a lot of these major systems on New Glenn. Megan is from Utah, and in a very sweet story, Megan is actually wearing a bracelet today that her grandfather gave her grandmother with charms for every Apollo mission that he worked. So a really incredible legacy of spaceflight in that family.
Legacy indeed. That's
to
crazy.
The Blue family. So just we're really proud.
I wonder
of
how
them
you got
today.
those charms.
Megan
like,
Lewis and team,
I guess they were,
led by Ben Dykstra, are getting it done.
Like, I wonder if they were like self-made or.
I love it. Just some wonderful stories, and each one of them has their, their ritual. I'm glad that seems like their alarm system.
They might have a cafeteria working on launch days. They might actually, yeah, like SpaceX does.
That's a good thing.
Yeah, head on over to the rocket factory.
Hey, Maggie, stay
and get yourself an ice cream cone.
And we will keep checking back in with you. All right, everybody, we're at T-minus 11 minutes and 40 seconds to go until launch. Why don't we take a moment
God, we are so close to the 10-minute mark.
Checking on New Glenn as it gets ready for its first launch to space today.
What a powerhouse of a rocket chat. Soon, TM chat, soon. Why isn't launch control just like, just 3, 2, 1, go? Yeah, that seems like a perfect way to get fired and to possibly go to jail for FAA and all. Yeah, lots of problems with that. Yeah, and that is how RUDs happen. 100%. Yeah, because remember, they're still conditioning the vehicle. The vehicle is still constantly being, having its boil off, pressure managed. It's taking all of the gas that's boiling off because it's using cryogenic liquid oxygen, liquid natural gas, and liquid hydrogen. All of those super cold propellants are going to continue to boil off, and so they're constantly filling the tanks. What we're seeing here is a reflection to the flare at the bottom here. That flare is there to burn off liquid natural, or I should say gaseous natural gas, as well as gaseous hydrogen coming off the vehicle. So yeah, there's a lot happening here. We are just about 10 minutes out where they should go into the terminal count process. Haven't heard an update since earlier about the weather, but we'll see if we get an update on that here now. ULA snipers, yeah, hopefully they're in bed. Hopefully ULA snipers are in bed. There's the flare stacks that I was talking about that we were seeing a reflection in the fairing. Those are taking basically the gaseous methane and gaseous hydrogen off of the vehicle and burning it, because those are gases that are very volatile and you do not want them pooling anywhere near the pad, especially when there's venting oxygen and things that could cause spontaneous combustion. But also methane is a greenhouse gas, and there are regulations that you have to burn off. You can't just release a whole bunch of gaseous methane into the atmosphere. So yeah, things happening. Reflection is in a very sus location. That's what I was saying earlier. But what's good about that is that hose at the very top there is actually just a vent line into the fairing, like for air conditioning and stuff like that. So that way, if you have a payload that needs to stay cool in the hot summer Florida days, they have air circulation. So that's not something that should cause any sort of fire or scorching, which is good. But yeah, definitely in a sus. sus location. What time is it for you? For me, it is almost midnight. It is almost Monday morning for me. I'm in Mountain Time. What's up, Hawk? How are you? Because of how they are. Yeah, you can tell which one is methane and which one is hydrogen. Yeah, hydrogen burns pretty clean. Liquid natural gas burns bright orange. But yeah, so you have liquid natural gas, liquid methane, or sorry, liquid natural gas burn off here and hydrogen burn off. Yeah, LNG, all good. LNG is essentially just methane. It's just not pure methane, right? So, yeah, whatever. You should know what... Ah, they recycled the count. Recycled it, chat. Pushed it back. Yep, that's right. Pushed it back. We're back now to 30-minute mark, essentially. Who said it? Who said it, chat? It was one of you? It wasn't me. All right, so pushing it back another 30 minutes. Like I said, they have a 3-hour window, chat, and we're only an hour in. So technically speaking, they have another 2 hours to keep kicking the can down the road. So we'll see. One of these will hopefully stick, though. We just need one of them to stick, and then we'll see a launch here. Oh, look at that, chat. Really good close-up of a vent line here. Liquid oxygen vent line on the second stage. So this is the forward module that I was talking about earlier. These have the actuator motors for all of these fins here for attitude control, for aerodynamic attitude control. And then we have all of the reaction control thrusters here as well that I was showing earlier being tested.
Time to the clock, as we mentioned before. This is just our teams getting aligned, making sure that
more time to enjoy the view. There you go. Look on the bright side.
Gone through all of their checklists, make sure that everything is in the green, making sure that the weather here at the Cape and downrange, everything is within bounds. So again, if we need to add a couple more minutes,
kicking the Dan down the road, exactly.
But while we've got a little bit more time, I would like to check in with my colleague Eddie.
The ice buildup is getting thicker. Yep, it is.
Where he's joined.
What's going to be cool is that all that ice buildup, right? If we actually see a launch tonight, will you know, when the rocket engines ignite and the whole vehicle shutters, all that ice will just fall off.
Family, we're working at Blue Origin, and working on rockets is a family
operations
affair. I'm with Father Mike Corbin, Mike Smith,
Ops
son,
and
Corbin
MFG
Smith, and
team.
MFG. Elizabeth, tell me, you've sent a postcard
Flight
to space,
guidance?
is that right?
Yes.
And tell me, what was
MFG?
On your postcard?
There was rockets and planets.
Rockets and planets on the postcard. Now, Corbin, how did you get your start at Blue Origin?
So I first started up in Huntsville.
I was wondering
where
about
I worked with
manufacturing.
An amazing team on the engine crew, building BE4 and BE3U. Now I'm here down at Rocket Park, building the thrust structures for GS2.
Excellent. Must be special to be working on that GS2 rocket out there. And Mike, how about you? How did you get your start at Blue?
Well, it was my son that actually encouraged me to apply, and
oh hell yeah,
got hired around the same time.
Look at that!
And it's been awesome being able to work with him.
Father-son team
projects. We get to
mission
talk about
flight guidance
home,
could be
and do different things. We bleed blue at home.
Excellent, excellent. And Elizabeth, tell me, what are you most looking forward to today's launch?
For the rocket to go up in space.
Well, I think we're going to end on that note, Ariane. We're looking forward for that rocket to go to space. Let's send New Glenn to space. Let's light this candle.
I love
manufacturing.
It is a family affair, and I think I love seeing the different generations there. Father, son, pair working at Blue.
Reasonable expectations. Yeah,
that little
yeah,
firecracker, that little girl
good family
joining
there.
us in a couple of years here in the future. It just speaks to, you know, it takes years to build these rockets, and that's what we're here to do at Blue. We're here to build these rockets.
All right, they're just filling time now again. So we're 24 minutes out, chat. But yeah, as I was saying earlier, if we wanted to see, I accidentally exited, but it's a good thing I have all of my notes and pictures here, chat. We can go back to it. So that's the static fire that we talked about, but the aft module, sorry, not the aft module, the forward module. This is what I was talking about earlier. This is the forward module that's on the very top, basically the inner stage where the second stage engines sit inside and the second stage actually integrates to the top here. But yeah, these are all of the attitude control thrusters. This is what is going to control the rocket, because remember, it's taking off this way, Second stage is going to separate and continue to go, but in order to orient itself for landing, it's got to do like a 150-degree swing to go engines first and backwards, essentially, for a landing. So it's interesting as well. We heard it earlier. This vehicle does what's known as an exo-atmospheric deceleration burn. We all know it here as supersonic retropropulsion, but they call it the what is it? EDB. Yeah, the EDB, exo-atmospheric deceleration burn. So we'll see that hopefully from an onboard camera. That would be pretty wild, no doubt. We also saw for this forward module testing the fin actuation. So I'm hoping that during the final checkout, we'll be able to see a very similar wiggle to this, because New Shepard does a fin wiggle right before launch, the smaller vehicle that Blue Origin operates for space tourism. So hopefully we'll be able to see something like this. We do know that we should be able to see the engine checkout. Basically, all of those BE4 engines that we saw in that quick camera view, all of those should do a gimbal checkout as well right before launch. So we'll see. We will anxiously await all of that to come. But yeah, that ice is really building up, chat. You can barely make out the Blue Origin company name. The American flag is a little bit more prominent. But yeah, very, very cold. We anxiously await as we're approaching the 20-minute mark again. The ever unforgiving 20-minute mark. So this brown stuff that you see on the wings here, that is the thermal protection system. Blue Origin calls it internally COMET, C-O-M-E-T. To my knowledge, it doesn't stand for anything. It's literally, like, at least when you see it in articles and whatnot, it's just sentence case. It's a capital C, lowercase O-M-E-T. They call it COMET. It is a Blue Origin in-house built thermal protection system. So we'll see. The 20-minute mark of doom. Yes, indeed. The flag isn't big enough? Yeah. You can hear the ambiance here at the pad. You can hear all of the pressure regulators. You can hear the pumps going off. All of the hisses and whines. Sounds like a rocket launch, chat. Yes. Yes, it does. I wonder if they're actually going to burn outside the atmosphere. They keep saying that they do the burn, then re-enter, but SSRP is specifically done during re-entry and also operates a bit like a E-shield. Yeah, I'm not sure. Yeah, that's a good question as to whether or not that's the reason why they don't call it supersonic retropropulsion. Because if they are actually doing it at, say, 100 kilometers or above, then yeah, technically speaking, that would be not supersonic, right? So that would be outside the atmosphere, outside the lower atmosphere. But yeah, I'm not sure. I'm not sure exactly what their flight profile looks like in terms of the altitude that they're doing these maneuvers. It seems like, at least from the graphics that they've showed, that it is supposed to be inside the atmosphere, almost like a deceleration burn that SpaceX does. But we'll see. We'll see specifically, hopefully. Technically, ISS is inside the atmosphere. Well, technically speaking, the moon is inside the atmosphere. You guys have seen that article that NASA's found Earth atmosphere out beyond the moon as well?
T-minus 19 minutes and 55 seconds to go until launch. New Glenn looking good there on the
All right, we made it past 20 again. Can we make it down to 10?
All the propellants are nice and chilled down. You saw the big, beautiful Blue Origin word mark and feather.
We're inside the moon's atmosphere. Ah, yes, of course.
But we do have a little bit more time here.
They go with nailing welding the legs to the ship's deck once landed, or no? I'm not sure exactly what they're going to do with that in Misadventures.
Oh, that's a pretty shot right there. You see the 7 nozzles of the
oh my, did it get a little warmer in here, Chad? Or is that just me?
This one is powered by 7 BE4 engines.
Those are the BE4 engines on the first stage?
First, reusable, oxidizer-rich stage combustion booster engines. They use liquid oxygen and liquefied natural gas, or LNG, which is essentially a commercial form of methane.
Yeah, and we selected LNG because It's cleaner burning and more efficient than
What I say,
kerosene,
chat.
or also known as RP1, rocket propellant.
It's also
one,
much
a lot
easier
of
to procure.
rockets use. It's also low cost and widely available, which is really important when you're doing lots of launches.
It's a smart move, honestly. I really like that they're using
that we have done a ton
liquid
of
natural
testing
gas
on the BE4 engine, and we also want to keep those costs down as well. All of it adds up, right? And
around
one
the
of
engines,
coolest
yeah.
aspects, though,
Yeah, they're
about
probably chilling the
LNG
engines
is that
down.
It can self-pressurize its tank through a process known as autogenous repressurization. Right?
Autogenous?
So this eliminates the need for costly.
Is that actually how it's
complex
pronounced,
systems
chat?
That use helium, which is pretty rare. So normally you got helium.
Is it actually
and
autogenous? I always thought it was
other gases
autogenous.
in there to push the pressures properly through the engine.
I'm not an English major, so I have no idea, but I
with
definitely thought
LNG,
it was
it does on
autogenous.
its own. That's what
Pressurization.
It's so
But is it
fascinating. In
autogenous
terms of power,
pressurization?
each BE4 engine generates
You think
an
so?
impressive
Okay, well, you learn something new every day,
550,000
chat.
pounds of thrust. So when you combine all 7 engines, New Glenn produces
cool.
about 3.85 million
I thought it was
pounds
like
of thrust at launch.
heterogeneous.
And just to put that into perspective,
Right, heterogeneous.
that's
It's not
roughly half the thrust of a Saturn
heterogeneous,
V
right?
rocket, which
Or
took
whatever.
humans to the moon. Imagine
autogenous,
that
okay.
power of 200.737
Oh, it's
airplane
just
engines all
one valid
firing at
pronunciation?
once.
Oh, okay.
That's what we're looking at here.
And that is a ton of power. You see that these images here, this video, this is from our test facility down in West Texas. And man, oh man, I have been down there actually for one of these tests. And our facility down in West Texas is in this valley. And it just reverberates.
So
You
it
feel
does
like you're in the
have-
inside of a drum.
It does have on the ship, right? It does have this thing known as the RROV, or Robotic Remotely Operated Vehicle, or something like that, or reusable. I'm not sure. It's ROV, Remotely Operated Vehicle. And you can see it has this robotic arm to attach to like the system itself to give power and to view telemetry and to probably provide control and whatnot, right? But to my knowledge, I mean, this isn't like the Octo Grabber that SpaceX has on the barge. This is, I think, much smaller and only connects here. So I don't know how good this will be to try and keep that massive vehicle. Here's an engine section that we're looking at again, to keep the massive vehicle from slipping on the deck. So yeah, not sure about that one in terms of what they have there. Yeah, here's the scale of the engines, by the way, chat. So here's the BE3 engine. BE3, each one producing around 700 kilonewtons of thrust. That's 160,000 pound force with each engine. There is a woman for scale, 64 inches tall. There is the mighty BE4 engine. So if you're looking at this and saying, well, why is the BE3 engine so much bigger than the BE4? It's technically not. It's just the nozzle extension is huge because it's a vacuum optimized system. The engine itself is actually still very small. And we talked about this earlier. So the BE4 engine is known as a oxygen-rich staged combustion cycle. That means that all of the oxidizer, all of the liquid oxygen goes through a pre-burner and gets mixed with a little bit of the liquid natural gas. Those combust in the pre-burner, and that's what spins the turbo pumps to feed the rest of the rocket's engine with both oxidizer and liquid natural gas fuel. And so after the pre-burner, you have that mixture of highly oxidized exhaust, essentially. All of that goes into the combustion chamber, gets fed in with the liquid natural gas, and then you have combustion. The BE3U, as we said earlier, is a bleed expander cycle, or an open expander cycle, which is actually really interesting. It's one of the first that I've seen or heard of. I think the J2X was or the J2 had a variant of an expander cycle that was also open, which is really cool to think about as well. But essentially that means that the expander cycle, right, has no pre-burner, has no gas generator. It just uses the natural boil-off capabilities of cryogenic fuels. It soaks up the heat from the combustion chamber as it runs the liquid oxidizer through the combustion chamber channels, not into the combustion chamber, but basically around the outside in what's known as cooling channels. That liquid oxidizer or liquid fuel takes heat away from it, basically flashes into gaseous or two-phase gas and liquid, and that gas is what's able to spin the turbine. So there's like no burner. There's this much simpler design. But then it's an open cycle because it only uses some of that to then go into the combustion chamber to ignite it and combust, and the rest of it gets dumped overboard. So that allows them to have a very efficient, very simple upper stage engine, but also something that's actually able to achieve significant thrust, because expander cycles, if they're closed, meaning all of the fuel or all of the oxidizer go through the combustion chamber, you have a lot of pressure losses, and therefore you have a cap on your thrust output. But because they only use a little bit of the fuel and oxidizer to actually go into the combustion chamber, you have a lot higher combustion chamber capabilities, a lot higher combustion chamber pressure, I should say, so they can have a much higher thrust on those upper stage engines. And we have another pushback chat. Yep, it's all good. We'll just chill. We'll just talk about how cool New Glenn is. It's all good. We're just chilling. You've never seen so many recycles? I have. I don't remember what it was. Was it Vulcan? There was fairly recently one that did this. Or was it one of the earlier Starship flight tests? I'm not sure, but yeah. Artemis also had a few. Not only did Artemis have a lot of scrubs, too. So back to the 33-minute. I wish they would be a little bit more forward explaining why. Like, why the recycles, you know? I mean, you have plenty of time, so I know they're just checking the vehicle and making sure everything is right, but I really wonder what specifically they're waiting for. Like, is it something that they're not hitting in terms of a target? Or, you know, are they just going through additional checks? Like, it'd be interesting to know. Well, they're constantly filling it up. They haven't stopped filling the vehicle. So yeah, it's boiling off, they're filling it, it's boiling off, they're constantly filling it. Bob hasn't gotten back with the coffee, yeah. But yeah, we sit and we wait, chat. That's all it is. We sit and we wait. That's all we can do. How many times is the vehicle rated to cryocycle? Probably a lot. Probably a good amount. 20, 30 times. More, I don't know. We're about to find out. Yes, we sit and we wait, chat. 31 minutes. So we're coming up now on almost halfway through the overall flight window that they have, launch window. Their launch window, as I mentioned, is 3 hours long, starting at 11 a.m. Mountain Time and going all the way through 2 a.m. Mountain Time. So they could launch this at the end of the launch window, essentially. Yes, we sit and we wait, exactly. Oh, that's so true, Stealthy, yeah. Probably is several hundred. Because this vehicle is supposed to be reused up to 25 times, if I remember correctly. Yeah, this first stage is designed to be reused at least 25 times, so... yeah, hundreds of cycles. 6 hours later, the countdown will still be at 31 minutes. No, not 6 hours, but an hour. An hour, maybe. Yep, because right now we have about an hour. What is that? An hour and 40 minutes left in this window here. Yeah. In the meantime, we just chill with some good old New Glenn shots on the pad. Can you explain pressurized rocket engines to us? Why is Falcon not a pressurized rocket engine if the tank is filled with helium as it lowers in pressure? So, essentially pressure-fed engines, right? Pressure-fed engines are essentially, you can imagine on a launch vehicle, each of your engines has a specific operating chamber pressure. For example, the Raptor operates its chamber pressure at 300 bar, 300 times the sea level pressure. So that's very, very, very high pressure. 300 bar, super high. So in order to have a pressure-fed system feed your rocket engine, it must sustain 300 bar in order to push your propellants into the combustion chamber. Because how any sort of pressure works, right? Your injectors of that are actually feeding your combustion chamber with fuel and oxidizer has to actually be at a higher operating pressure than the combustion chamber. So if you're operating your engine at 300 bars, and that means your injector plate has to be operating at, say, like 350 bar to actually get enough pressure through it to actually fill your combustion chamber. And in reality, it's probably operating at more like 400 or 500 bar. So that means in order to push your propellant into your combustion chamber, your pressurant, if you're only using pressure to feed your engines, has to sustain 500 bar. And there is, much like everything in aerospace engineering, diminishing returns. You're going to require way too much pressurant in order to sustain that amount of actual pressure into your combustion chamber. So that's why pumps are great. Pumps are fantastic because they actually are a mechanical system that is able to take in a low pressure and pump out a high pressure. So that's why you use turbo pumps, which are essentially jet engines hooked up to a turbine, or I should say a jet engine hooked up to a what do you call that? A radial pump head, a shaft that's able to turn at really high RPM to suck the fuel in and push them out at a really high pressure. So yeah, there's a very limited point where your engines just become too big to where pressure fed is just an impeller. Thank you. Your pressure fed system just becomes impractical. Does that make sense, Graham? So yeah, pressure fed systems work great on small engines. Now, all of that should be taken with respect to the Sea Dragon rocket. You guys know the Sea Dragon rocket? It was going to be 23 meters in diameter. That's 7 stories tall, or sorry, 7 stories wide. Yeah, absolutely massive. You guys know Sea Dragon. That was supposed to be a pressure-fed engine. There's a reason, there are reasons, I should say, why Sea Dragon did not work.
40 seconds to go until launch.
Was not made.
You may have seen we've
yeah,
been
this
adding
guy,
some time to the clock.
you know this guy?
This is to allow
Sea Dragon,
our teams to go
550 tons to LEO, bigger than Saturn, much wider than Saturn.
We want to make sure
pressure-fed single rocket engine.
Everything is ready to go, and if some of those items on the checklist take a little bit of extra time,
but
we're going to do
needed
so,
massive amounts of pressurant to meet that requirement, and it was just impractical.
Everybody is prepared, and everything is aligned. We should also mention, again, we have to keep our eyes on the weather, both here and downrange. So with that, let's continue to check out New Glenn on the pad as this rocket and our teams get ready for NG1.
You think the F1 had issues? Exactly. Centrifugal pumps or axial flow? I mean, I think they're technically centrifugal. If I'm not mistaken. They have an impeller that spins really fast and sucks in and pushes it out the side. If I'm not mistaken. All right, 24 minutes, chat. I really hope this one sticks. Goodness. Goodness gracious. Now that's a rocket engine. Yeah, thick boy. Exactly. They look like snails? Yeah. Here, I'll show you.
Thank you again.
If I'm not mistaken, I could be mistaken.
T-minus 23 minutes and 45 seconds to go till launch. With all this action going on upstairs at launch and mission control, why don't we check in with our friend Maggie? Maggie, you got me?
Loud and clear, Ariane.
Right on. What
Something
are
like
you?
this.
What's going on up there? What are you hearing?
The radial
about,
impeller.
The status of our teams.
It's kind of a mixture, I guess,
busy.
but
the
yeah.
Team is continuing to work through a
Turbo
few
pump for liquid rocket engine. I mean, I know this is STL, but this is what they look like.
We've got the engineers looking at all that data. We've got the controllers working through workarounds. So something that I think people don't always think about is that we have
starting to dread it. Yeah, I know, right? Anxiety inducing.
It's, you know, scripted.
Yeah, centrifugal. Yeah.
But when off-nominal things are happening, we've got a team of controllers who can manually operate these systems.
Have we gotten to the point of asking the magic 8-ball? Yeah.
Bit, they are actually going through and able to turn things on and off, you know, put different pressure through different valves. They are working through everything they can.
Doing some office work at 1 a.m. Yeah, as one does for a rocket company.
Yes, it's, you know, we run through, when you talk about all the preparation for a launch, of course, we talk about, you know, testing the rocket itself, but we also go through a lot of these simulations in terms of the operations with our team. And you test as much as you can, you go through as many rehearsals as possible, but sometimes day of, you
Groundhog Day. That's exactly what we're in right now.
So that they can work through whatever it is they're finding that might be a little bit off, and that's what our team is doing up there. Maggie,
you know,
what
Ariane,
else? Sorry, go ahead.
No, you know, the team here has gotten some good practice. I think we all saw the hot fire that we recently successfully made it through. So that is, you know, almost everything up until launch. Before that, we had a successful second.
There's Jacqueline in the background. That's the landing platform out in the middle of the ocean.
Mass simulators. We've done
New Glen Day. Yeah, that's right.
And a lot of the engineers
have they checked for ULA snipers? I sure hope so.
Responsible engineers
Not sure,
on the
though.
floor. So they've gotten their hands on this hardware. They know their systems.
Is that me? Or?
Excellent. Very good point. I think that I've always appreciated what we do here at Blue Earth. We tend to rotate our engineers.
What is ULA snipers? It's an ongoing meme.
Down to the floor, see their hardware maybe that they've designed.
That ULA, the launch company, has snipers that shoot competitors' rockets to make them not work.
You know, they are
I don't remember how it started,
very
but
in tune,
yeah.
in touch with this vehicle. So if there are things for them to work, especially in these last minutes, we've
Isn't
got
ULA
the right
using BE4 engines? Yeah, they want the
Maggie,
BE4 engines, but they don't want a competitor.
For bringing us all the details. We've got a couple of minutes to go.
Give me all of your engines,
minutes,
but no rockets.
47 seconds to go until launch. Why don't we take a look at New Glen as this rocket gets ready to go to space?
All right, back to the ASMR that is pad operations. Been around since AIM 06, maybe? Yeah, I think you're right. Not a rocket. Exactly, Morden. Yeah. With a Facebook satellite? Interesting. Yeah, I know it's been around for like a decade. Been around a really long time. All right, the 20-minute mark is passed. We'll see what happens here, chat. We'll see what happens. But yes, this is looking very good. We still, like you said, we're only halfway through the launch window right now, so we still have plenty of time to work whatever they need to work out. So what we're looking at here is the basically major support tower that the vehicle is integrated into, with the thrust structure at the bottom. This tower also has a lot of the cryogenic propellant lines that fuel the second stage. We also saw at the very top it has those pincers that actually actuate and actually, you know, hold the rocket to the structure as well. Those should all separate here momentarily as we enter the final count. We just gotta get there, chat. So we just gotta get there.
Everybody for joining us. We are T-minus 19 minutes to go until launch here, and while our teams are continuing to get aligned, why don't we take a moment to chat a little bit about this amazing building we are in?
Will Blue Origin see its shadow and get scared? We'll see.
Florida.
Hopefully not.
This is where it all comes
Hopefully
together. Where we bend the metal on New Glenn. I literally see people
Oh dear,
down
Iceman.
there bending metal.
We got 18
pulling,
minutes. How long does it take?
You know, putting the
How long does it take
components
you?
together, testing, cleaning, but also not only do we talk about, you know, just all the intricate pieces and parts here, but to build a rocket like this, the sheer scale of the facility here, this factory, but also the other.
All of it is new as of like the last decade, chat.
It really is quite
Blue Origin has
impressive.
worked
So Rocket
fast
Park
for
is
this.
essentially where we bring our rocket dreams to life. We're talking about state-of-the-art manufacturing and assembly areas designed to produce rockets efficiently and, of course,
A
sustainably.
few years, okay.
This is where the stages of New Glenn come together.
Yeah, exactly. And the folks here at Rocket Park are not just building rockets, they're really shaping the future of space travel. You know, I should say, you know, I've had the good
All
fortune
right,
of being
we're
here
still
for 10
inside the
years
20-minute mark.
and I have seen this
We sit
facility
and we
the
wait,
whole
chat.
park, in addition
We
to
sit and
Launch
we
Complex
wait.
36 come together, and it is just amazing. Like really from the bottom up, and the ability to build the next generation rocket in the next generation rocket factory. Like our team is given what they need to make just an incredible vehicle. Why don't we take a deeper look at the home of New Glenn?
Over under on when it recycles again? No, I'm not doing that.
Rocket Park.
I'm not doing that.
The home of New Glenn. This is where our orbital rocket is designed,
Ooh, yeah.
built, integrated, launched, refurbished.
It is such a good looking rocket, I gotta say.
Within a 9-mile radius along Florida's space coast. Rocket Park is an active operations site
That's
for
their
many
massive
Blue Origin activities,
manufacturing
including
facility.
Manufacturing, integration, and testing for New Glenn.
Look at those BE4
and production
engines.
of our Blue Moon lunar landers
Oh,
and future
there's the blue
programs.
ring.
Florida's space coast is 72 miles long.
Atlas.
And steeped in more than 6 decades
Saturn.
of human spaceflight history. We stand
Shuttle.
on the shoulders of giants. New Glenn will help us build a road to space for the benefit of Earth. It's the foundation of everything we will accomplish. It will deliver cargo and crew to anywhere, including the moon, and help us establish.
And then the upper
permanent
stage exploded. Oh
lunar
god.
presence. It will enable us to
No
harness
such
the
comments
resources
like that,
of
Hellfish.
space and
So
launch
that's blue ring
all
right there that we
kinds
saw
of
earlier that
infrastructure
they're
to
testing
make
on this
space
flight.
accessible, usable, and affordable.
And goodness me, I hope we can see that.
The factory on Merrow Island is the centerpiece of Rocket Park. It's here where New Glenn is built and tested. The high bay is where New Glenn becomes real. Raw material enters at one end, and completed rocket stages roll out the other side.
Nice. There's
From
the second
there,
stage.
New Glenn heads to the surface coatings facility for its thermal protection, paint, and artwork. It
Look at
then
that
heads to
massive
tank cleaning
fairing.
and test, or TCAT, for pressure testing and cleaning. The factory is also home to New Glenn's Mission Control.
That's what we saw in the
On launch
background
days,
earlier.
Mission Control comes alive as the rocket rolls out from its hangar down the road and goes vertical
At least their lunar lander makes sense. I agree.
This historic launch site was rebuilt from the ground up just for New Glenn. Protected by 2 lightning towers, almost double the height of the Statue of Liberty, New Glenn prepares for liftoff at mile marker 0. This is where the road to space begins.
What a beautiful area Rocket Park is in. There's just so much history here
Pretty
on
cool.
the Space Coast.
Pretty cool
And we are eager
promo
to
video.
write our own chapter with New Glenn.
Absolutely. There really is just so much history, and there's something to be said about the testing and integration and design teams all working so closely together. I know that working on the programs myself, being able to talk to the designers and the people who are making the hardware is just so valuable to increase communication and efficiency. And our
All right,
candidates
Iceman,
really
sounds
love
good.
that.
100%. The physical proximity is really, really important. And it's not known, actually, but historically, rockets have launched out of the Cape, but they haven't been built here. And so to be able to build our rocket here, do the integration here of the rocket, but then also obviously the payload with the rocket.
Yeah, it's true.
And then when we get
Like
GS1,
ULA
the booster back, we'll be doing all of the
develops them all in
refurbishment
Alabama
here.
and moves them
That
here
is
by
so
ship.
important,
Literally,
that
it's called rocket ship,
communication,
right?
to have that all come together.
And
You
goes
know,
to the
I love
Cape
that
and
video
unloads the
'cause
rocket.
you see all the action, as I mentioned.
Same with
you know,
SLS. Same with
it's so
Falcon
fun. I was
9.
looking
Falcon
through
9 gets
photos,
delivered from
earlier
Hawthorne.
today, and I've got photos
Yeah.
in the flame trench when they were just putting it up. You know, they were pouring concrete. You know, I remember being in this facility when there weren't doors on. It was just, you know, dirt on the ground. I remember no joke, we had a poll when they were clearing the land for this rocket park as to how many turtles we would find, because we have to relocate all of the turtles because there's
That's pretty
incredible
crazy.
wildlife in
Yep.
this area. So of course we.
I mean,
wanted to
NASA
make
Cape
sure we
Canaveral is
protect
on
those animals and the wildlife.
nature preserve.
And so we had a poll as to how many turtles we were going to find. God, I wish I could remember.
I was going to say, do you
I know,
remember?
I know. I didn't win it, clearly. But, you know, there's just so much work that went into building this facility from the ground up.
Even the
and to
Saturn
be
was
here
flown.
today
Yeah, that's true.
Is just,
Yeah, floated in.
It feels surreal in many
That's
ways.
correct.
And, you know, that I was just talking a little bit about the factory itself, but the launch complex, you know, LC-36, as you touched on earlier this evening, has been around for a
Falcon
long
9
time.
upper stage with a
has
Tesla
been
Roadster.
Where many
Or
historic
Starship.
rockets and missions
Pretty
have
good.
launched from. And we basically stripped it down to the ground and rebuilt it for this world-class rocket for decades to come. You know, we invested in this facility knowing that we're going to.
Well,
With that said,
yep,
we
recycled.
also here at Blue Origin like to pay homage to
Recycle chat. 40 minutes now.
who have the shoulders upon which we stand, right? Like the vehicle, of course, is named New Glenn.
Recycled 40 minutes.
But also what's really cool is, and you can't quite see it here in the dark, but we kept what's called the blockhouse. So a lot of the previous, during a lot of the previous
Again,
launches,
I wish they would just
there
tell
would
us why.
actually be a crew in the blockhouse.
That's all I want is just a
not
little
very far from that launch
info.
pad
Would go a long
when
way.
they launched a rocket. This thing is like a concrete fort, basically. It's not very big.
Not
It's
with
just
that
on the
attitude,
inside, it's got
Naps.
these massive, heavy doors that close to protect the teams.
Why'd you set your alarm so early? I know, right?
Using that blockhouse tonight. We don't use it in our operations, but it is something that we have kept on
Ooh,
site.
I like this shot, though,
because
of the BE-4 engines.
The history that is in that facility. I hope that one day I'll be able to go back in there. I did get a chance to peek my head in a couple of years
Bob's
ago.
cat stepped on the
feels
mission
almost
control
like
buttons, reason for delay. That's a bummer, yeah.
What's the right way of putting it?
That's a bummer.
It feels like a step into the past.
Yeah.
You know, the old computers. and
Again,
like,
we sit
you know, the
and we wait, chat.
ashtrays, they're
We sit
literally
and we wait.
cigarettes that are still there.
Yeah, really
Back
nice
in the
thermal
day.
shot, yeah.
We don't allow that in our launch control rooms. But again, clearly a throwback to the past. But just this facility, it feels really good to be here. It feels like we are we're set up
Like
for
a red
success.
team incident, Panda?
Really, really
I don't think so.
Okay, we are at T-minus now 36 minutes and 40 seconds.
I can't believe
to go
that happened for
launch,
Artemis
and
1. You guys
our
remember
team has
that?
added more time to the clock.
The red team had to go to
They're
the pad with the
working
rocket
through
fully
their
fueled
checklist.
and was like, you know
There's
what?
clearly some things that they want to
Try
spend a
taking
little
this
bit more
torque
time
wrench and
on,
just
and
putting it a
that
little
is okay.
tighter.
I will
And that's what they
reiterate.
did. And then it launched.
We have spent years designing this rocket. We have spent months and months designing this mission, building this particular vehicle as well. The design and test that's
Too
gone
late for you.
into the
Good night. All right,
engines
Teague.
that are
Have a good night,
powering
my
this
friend.
rocket. If we need a couple more minutes, especially on this first
Nope,
launch,
nope, Mark. It is, it's a 3-hour launch window. So technically speaking, they still have another hour and 20 minutes in this launch window. So
that they need to
depending on what they're going to do,
work on whatever they
might
got going
only
on up
have
there.
time after this to
I
recycle
also wanna,
once more,
keep in
and
mind,
then they're
my
either launching or they're
understanding is
not.
that the weather continues to stay inbounds here at the Cape, as well as out at sea. But for the moment, we have decided to put more time on the clock, which means that we still have a chance, still have the opportunity to launch this evening. I should say,
I was waiting
Delay
for it.
maxing,
I know,
yeah.
it's pretty apropos because this vehicle says.
So you're telling me there's a chance?
That is the name of this booster. So yes, everything is. It's like it was meant to be for this vehicle.
It really
Okay.
is.
With that, we are T-minus 35 minutes to go until launch. Let's continue to check out
All right.
Cleveland on the pad.
We sit and we wait, chat.
As it continues to prepare for its launch to space this evening.
We sit and we wait. That's where we're at. Back to pad ASMR. So yeah, New Glenn definitely being a little shy. To be expected when you have a 3-hour launch window. Like technically speaking, you have a 3-hour launch window. Why wouldn't you take up a lot of that time, right? Make sure everything is good, like good. But yeah, it would just be nice to have a little bit more like actual words from LD. Like the one thing I wish Blue Origin would do for all of their broadcasts and whatnot is if we could actually hear some of the countdown net. That'd actually be really, really nice. But we're not so lucky with them, unfortunately. That is on a drone chip of SpaceX already, I thought. I don't think so. Not that I'm aware of, Graham. No, that's the name of this booster, though, apparently. Nice view of the ice sliding down the hall, indeed. Yeah, so, I mean, like I said, it's fine. We'll just chill. Got another half hour and see what happens. Seems like you get to work later today. Hey, fair enough. I like where your priorities are. Does New Glenn have onboard cameras? They have at least one inside of the fairing. So they have one up here. I don't know if they have others. I hope they do, but we haven't seen them yet, as far as I'm aware. It's cool. It is cool. In more ways than one. What would be the backup window if it's not happening tonight? Well, I think technically speaking, they could just do a 24-hour turnaround. Like, they're not... I think they're just trying to hit a specific orbit, but they're not, like, beholden to trying to catch, like, the ISS or anything like that, so... I think they could just do a 24-hour turnaround. So long as nothing else is wrong with the vehicle or something. Or the pad systems. Because that's what they did last night, right? It was originally supposed to launch this time last night on Saturday. But then they pushed it back to Sunday. Or technically Monday, I guess. So yeah. Wow, Naps, that's wild. I hope it's like SpaceX with all the cameras. I do too, but I will say if you've seen other Blue Origin New Shepard launches, they're pretty, yeah, unfortunately they don't use a lot of cameras at all, unfortunately. So, I'm not expecting too much. I am glad they at least have the payload fairing one, but we'll see. We'll see what happens. Maybe they'll surprise us. Maybe they'll surprise us. It's the first time they've launched anything of this class. You better believe you'd take every delay. Yeah, exactly. Like I said, when you have 3 hours and there's no real hurry, just make sure everything is working. But where I really would like to hear at least the countdown net is to get a little bit of an inside view on what the LD and the team is actually working. Are they working a problem? Are they not meeting? Are they not meeting a certain criteria that they need for launch? Is it an actual problem that they are working, or are they just, running through checklists essentially and making sure everything is good, since this is their proto flight system? Remember, this is a flight qualifying flight. Their first launch is supposed to certify them for the National Security Office. Yeah, so they have this. This is a big deal. This is supposed to certify their launch vehicle. So you better believe they're trying to do everything correctly and make sure everything is good. Where I just wish we could learn is, like, are they working a problem, or are they just running checklists?
At Blue Origin, as we've said time and time again, we're building a road to space for the benefit of Earth. This vision isn't only about
really, Morden? It wouldn't really surprise me, but
about making life
I'm not sure.
better here on Earth. Let's check it out a bit more about our vision.
New Shepard is just the beginning.
The first step.
From the very start, it's only been.
Was that William Shatner?
Earth.
Earth, our Blue Origin.
We've sent robotic probes all over the solar system, and it's full of wonders. Gas giants, rocky moons.
They haven't made it to T-10. They have not, no.
It is not close.
They've made it inside of T-10, but never done a poll or anything, and they've just recycled, so.
There's no place like home.
Earth is our home, and there is no other place like it.
All life on Earth are uniquely matched to this planet. There's nothing like it anywhere else in the solar system. Not even close, no way.
We have no choice but to preserve Earth.
Preserve this planet.
Yeah, I know, Jan. That's why I was asking if that was actually a shot of Shatner's flight.
The future is nothing without Earth.
For almost all of human history, Earth has seemed big.
It seemed big, but we now know it's small, it's finite. And we know that the rate that we're using Earth's resources is not sustainable.
Earth has things that we need to work on in the here and now.
But there are also long-term problems.
We can't wait to work on the long-term problems. We have to work on both.
One fundamental long-term problem.
We will run out of energy on Earth.
I'm in Colorado in the United States. So
Humans have always
mountain
used
time.
about 100 watts of power. That's our natural metabolic rate.
Colorado, baby, that's right.
In our developed technological society, we use over 10,000 watts of power per person.
Humans' use of energy is not actually a bad thing.
We live in an era of dynamism and growth.
There are so many good things that happen.
I'm trying to understand, what is this video actually
Think
doing?
about technology, transportation.
It started off as like, Earth is awesome, Earth is our home, and now it's like, Earth is dying, we're killing it.
When we are making progress.
But humans are doubling our energy use every 25 years, and that's unsustainable.
You were there once?
Today,
Awesome, yeah.
You could cover all of humanity's energy needs by covering the state of Nevada in solar cells.
Oh, perfect. Just cover
But
the
at that
entire
rate of
state of
growth,
Nevada.
In 200 years,
Great, wonderful.
You'd have to cover the entire planet in solar cells.
What can
B-roll?
we do?
Yeah, I know.
Can we
I'm
be
just still
more
trying to understand,
efficient?
what's the message here?
Yes, but we have been.
Today's technology,
Especially from
is
Blue
more
Origin,
efficient
a
in nearly
launch
every
company.
manner.
We are gaining efficiency. And
Have
yet,
y'all seen those
when-
papers? I've talked about them on stream before. There are papers that show massive holes in the ozone layer coming from the large shock waves off of launch vehicles. So it's like what is Blue Origin's message here as a launch space company for I don't know, are they promoting something, or just, Earth preservation awareness? I'm not sure, but it's a little yeah, placeholder video for sure.
Practically limitless. If we can learn to harness the power
Ah,
of space,
there they go. They bring it full circle. Space is limitless. We can tap the limitless resources. Yes, there we go.
We can go to space for what we need. We'll make it routine, safe, and cost-effective to get there.
We will build the rockets and the destinations for doing real work in space.
All right, we're back inside 30 minutes, chat. Minute by minute, second by second.
Industries from Earth into space where they can't hurt the Earth or the environment.
We can return Earth to a beautiful natural state. It will be like a garden, like a national park. A place for education, for creativity, and for recreation.
A place for enjoyment and for nature to thrive. In space, we can expand humanity. We don't want to leave Earth behind,
Looks like an Orion
but
drive.
preserve it and expand humanity into space.
We can have 1 trillion humans in the
How much
solar
is the
system,
weather
which means
favorable for launch? I think, I actually haven't heard of the specific probability of violation, but because I haven't heard it seems like it's pretty good. And the landing zone, which has been the big ticket item, the landing zone being really rough out in the middle of the Atlantic has been what's delayed this since last Wednesday. So it seems like everything is good now. Ooh, yeah. Those massive cylinders that they've been putting out renders of. So yeah, the cool thing about Blue Origin is that they really are trying to do a lot similar to SpaceX, trying to basically commercialize, I guess, the solar system, being able to literally move Earth or move people off Earth to work in space and grab resources in space and whatnot. So that's actually really cool. So Blue Origin does have a pretty awesome future vision, as they've been talking about in that video. But yes, we're now 25 minutes in, chat. I'll beat on the space construction drum again. Until we learn to build not just Legos in space, we won't go anywhere long term. Yeah, there's a lot of things that have to be fixed. Not necessarily fixed. A lot of things that has to be figured out, right? Like the big one. Everyone is talking about, oh, I can't wait for SpaceX to send people to Mars in 2030, or to send a Mars sample return mission using Starship. But we forget that the thing that allows Starship to come home, at least in terms of the concept of operations that I know about, is that they have to have fully functional ISRU to refuel Starship on the surface of Mars to bring it back. And ISRU is still not a thing. Not at the not at the scale that Starship needs, right? Because I think for Starship, like if you don't want it to take years and years and years to refuel Starship, like you have to have a lot of power. Like we're talking, I think the concept paper that I read was like somewhere on, you need like a nuclear reactor in order to power the ISRU elements, in order to refuel all of your Starship systems, to bring back even one Starship. So it's crazy. Like the problems are very difficult when you talk about scaling up to something like that. But not an insurmountable problem, certainly not. But yeah, it's not like SpaceX is just going to pop on over to Mars and then just return. No, there's a lot that has to actually happen for that to work. It's a really cool video, though, looking at all the concepts for resource mining. There's Blue Moon. Blue Moon, I think, is supposed to have a demo mission this year, isn't it? Is Blue Moon supposed to have a lunar demo mission this year from Blue Origin? I was thinking it was, but that might slip, right? Because it actually has to launch on New Glenn, if I'm not mistaken, and New Glenn is still technically not operational yet. So. Like if you had a nuke's worth of power, you can condense methane out of the Martian atmosphere. There's some, I don't remember the concept there. But yeah, something like that. Because there is like, what, 0.2% or 2% carbon dioxide in the atmosphere there? In the atmosphere? Or is it more than that? And I think it's more carbon dioxide than that, but the atmosphere is 2% out of Earth. So I think that's the metric I'm thinking of. But yeah. It's still not a lot. You need a lot of power to get there, so yep. SpaceX is the Expanse, Blue Origin is Elysium. No, that's fair. I think that's actually a fairly okay comparison. Oh yeah, the cylinders, chat. Those things are massive. If anybody has read Rendezvous with Rama, it's basically that concept. Massive cylinders that can spin to give artificial gravity, and yeah, or like Interstellar, right? The large cylinder style of spacecraft. Yeah, you definitely have to have a hydrogen source. Because you need CH4 for methane. So you need carbon, and you need hydrogen. So ideally you have something like water that you can separate the hydrogen and the oxygen, so you can both get oxygen and hydrogen from it. And then you need carbon, and you gotta fuse the hydrogen and the carbon. So yeah, like I said, yeah, the O'Neill cylinders is what it's called, yeah. But yeah, like I said, it's a technology that technically doesn't exist anywhere near that scale right now. Anywhere near it. Like, not even close. Not at that scale for Starship. Almost 100% CO2, but 2% of Earth's atmosphere. Got it, yeah. Yeah, cool. Yeah, I mean, like I said, it's not an insurmountable problem. It's doable. It's just, it takes a lot. It takes a lot. And people are like, oh yeah, we'll just send, SpaceX will send Starship to Mars in the 2028 timeline. No, well, they might send one there, but they're not going to get one back. No Mars sample return mission for Starship anytime soon, I don't think. You say 50-50 for the launch day? Yeah, we'll see. We got another hour in the launch window. So we sit and we wait. That should be the name of this broadcast here. We sit and we wait. No new science, but engineering to the gills, exactly. Because that paper that we read, I did a whole on YouTube video of the concept paper that we were talking about, establishing the feasibility of Starship for Mars missions. And I actually thought I did a pretty good job. I thought, with some of the new things that came out in terms of metrics, like new performance or technical specifications we got from Starship, I thought I did a pretty good job on some of their calculations and assumptions used. But yeah, they're talking about like you need, with how it stands currently, even if you like scaled up the current best ISRU platform we have, you would need like 200 metric tons of stuff to bring with you to refuel a Starship. So that's like all of the ISRU equipment is like 200 metric tons. So you basically need 2 Starships to bring back 1 Starship, because 1 Starship, right, only has around 100 metric tons of maximum capacity, and you need like 200 metric tons of equipment to do it. But yeah, it's pretty crazy. Like it, and then don't forget, each Starship to bring 100 metric tons into orbit needs full refueling, which is like 15 refueling flights. So to bring back 1 Starship, you need like 17 flights. You need 15 plus 2. So it's kind of crazy. Well, actually, no, technically you need 30, right? Because you're sending 2 Starships to get back 1. So yeah, you need like 30 flights. You need 32 flights, which is kind of crazy to think about under current assumptions. All of that can, of course, change and probably will change with some SpaceX ingenuity, but that was the paper that we read, which was pretty interesting. Starship needs to perform refueling in space, and the heat shield problems, yeah, very true. Heat shield problems, I would like to think, are solved with version 2. There's some really cool pictures that we'll talk about before the launch on Wednesday, right? Because flight test 7 is, I think, still scheduled for Wednesday, if I'm not mistaken. That show some of the things done to reduce the heating problems on the forward flaps. So I'm hoping that is good enough. But there are, of course, other things that have to happen. In-space refueling demonstrations are definitely going to need to be demoed. The scale of that seems insane. Yeah, Spotch. It's pretty significant. It's pretty significant for sure. how much better is the fuel requirements if they don't do the get there as fast as possible route? Also, the fueling bottleneck is just to have Starship be able to get any significant payload to Mars. And that's assuming optimal Mars flight window, which is every 26 months. Yeah, remember, Starship has 100 metric ton capacity to low Earth orbit and no further. So you have to have either a refueling depot that it can go to, or then you have to send up 15 Starships under current assumptions to refuel that depot or that Starship. So the bottleneck isn't the transfer window or anything like that. It's literally Starship. Starship is the bottleneck. It's the fuel required to take any sort of large payload beyond just low Earth orbit. And when we're talking about colonizing something like Mars, we are talking about literally hundreds of metric tons of equipment required to do so. Like, remember, there's a reason why Elon Musk came out back when it was BFR, or maybe it was even ITS still, and he was saying that in order to colonize Mars, we would have to send megatons of mass to Mars every flight window, which would require like 2,000 starships in that flight window, which is crazy to think about. And there's a reason for that. It takes a lot of fuel to move a lot of fuel and a lot of payload. So yeah, Starship is awesome, but also it has a lot of things that need to be worked out, which is of course with any new system, right? Not an insurmountable problem. It's just, how do we best make it work? All right, any updates? Nope, still just listening to Pad ASMR. We just need to build a lunar or Mars cycler. That'd be pretty cool. I think there's a lot of really good technology that needs to be developed, but we'll see. What I'm hoping that this doesn't happen, but I guess what I'm a little bit worried about is that we are going to eventually fall into kind of like what we already are doing now. Fall into the, oh, this company or this system worked, and so now we're going to put all of our eggs in this system, you know? Like, people, you already see this online. Everyone's like, oh, scrap SLS, scrap this, scrap that, and SpaceX can do it all. Well, it's like, I kind of hope not, because there's like a lot of really cool technology that could be better than what even SpaceX can bring forward to do a lot of different things, right? So definitely not just scrap everything. I'm being a little bit hyperbolic here, but hope the sentiment still comes through. All right, chat. Golly, 14 minutes, man. We have 1 hour remaining in the launch window. We'll see what happens here. But yeah. Because you're already seeing that. Like, just let SpaceX do it all. Well, it's like, you know, there are things that Blue Origin are working on for like long-term, long-distance travels. You know, they're developing their own lunar landers, which I think is great. Like, SpaceX has developed Starship for really one purpose, and it does that one purpose pretty good, and that is getting a lot of mass to Mars. But it still needs a lot of support infrastructure to be developed to be able to do that. So yeah, having things like cyclers or O'Neill cylinders or other things like that could be amazing, and I just hope that in the future we have room to do so. I know, and that's what I don't like, Hellfish, honestly. That's what I'm saying. Are we going to go under 10? Well, now that you said something. Now that you said something. No, I don't think we are. We settle on what works, yeah. And it's fine. Uh-oh. Uh-oh, chat. T-0, we're launching. It's happening. it's T-0, chat. We sit and we wait. Yeah, is it taking it down off flight pressure, or is that just the vent that was happening a second ago? That's a big vent. Are they taking the... That's a big vent. Are they taking it down from flight pressure? Because if that's the case, then yeah, we might be scrubbing tonight. Is it a confirmed scrub, or you're all just assuming? They haven't recycled, though. Oh. They're scrubbing the launch attempt of New Glenn this morning. Not sure when it will be made final. Okay. Well, there we go, chat. Yeah, 3:15 a.m. Eastern was original. But from Eric Burgerman, it seems like they have scrubbed. And they haven't recycled the count, so it seems like they've been scrubbed. Okay. Well, we'll see. We'll wait for the confirmation here, or for the broadcast to end, or whatever's going to happen. That was from 3 minutes ago from Eric Burgerman. The scrubbing launch attempt of New Glenn this morning. Not sure when it will be made official. Okay. So then it might be a 2-day. Wow, a 2-day delay would mean it would launch on the same day as SpaceX Flight Test 7. Yep. Well, like I said, we sit, we wait. We'll wait for the confirmation here. Yeah, unfortunately, you know, that seems to be a little bit a standard of Blue Origin, you know? Seems to be. We're definitely spoiled with SpaceX, let's put it that way. SpaceX allows us to listen into the countdown net. They give us, you know, fantastic commentators that are constantly in the loop as well and bringing us all the updates. Blue Origin's not there yet. That's not the way they work, so. Yeah, we've definitely been spoiled by SpaceX for sure. But yeah, when I saw that big vent, that's them. It sounds like, or seems like, that's them bringing the main ox tank on the first stage down from flight pressure, which is generally a telltale sign that you are scrubbing for the day. So here's the problem, trying to fix it. Even NASA says that. Yeah, I know. Blue Origin tries to do good in production, but yeah, I wish that they would be a little bit more transparent and everything else in like their comms. Like, I would rather have like worse production, but better communications. But maybe that's just me, I don't know. Yeah, Graham. We're just waiting for the official. It seems pretty certain that it's been scrubbed, because it seems like they did a big vent off of the ox tank for bringing it down from flight pressure, or at least it seems that way. I haven't really been able to tell if that vent has always been like that. I was trying to scrub back through and see, but it doesn't seem like it's been like necessarily that strong where it was originally, because you can kind of see it there in the playback, but it doesn't seem like as strong as it was previously. So seems like they're bringing it down from flight pressure a bit, but we'll see. We'll sit, we'll wait. We will get confirmation here, hopefully, whether from Blue Origin or whatnot. But also, ISRU doing some rendezvous and proximity operations, which is pretty awesome with their Spade X. Waiting new T0. So this is NSF. NSF is also giving us a bunch of different views, which is awesome. Yeah, I'm totally fine with the scrub. Like this, you scrub when you're not ready to launch. Like that's totally fine. There's no rush on this. The customer for this mission is Blue Origin, right? So it's just kind of a bummer we don't get to see a beautiful rocket launch and make its debut. Did an interview with NASA employee. Apparently, Super Draco had to be throttled down because it was way too powerful to test the orbital maneuvering of ISS. Oh, interesting. That's cool. That's a pretty neat factoid. Getting chocolate ice cream and going back to sleep. I like it. I like it. But yeah, without the countdown being recycled now, and we only have 40 minutes left in the launch window, doesn't seem like they're going to do it. Hopefully we get a day launch. Yeah, I'm not sure. They've been pretty consistent at 11 p.m. If they're trying to hit a specific orbit, it'll probably always be at this time, unfortunately. But if they do have some leniency, since... Yeah, I'm thinking it'll always be at 11. It's been at 11 for like the last week, you know? So they're trying to hit a specific... Either they're trying to hit a specific window, or they're trying to hit a specific orbit. But we'll see. Any updates on Twitter? No, nothing on Twitter other than from Eric Bergerman that said he's confirmed that it's been scrubbed, but he's not an official source. Aha.
Just been getting an update from Mission Control. We are standing down today's launch attempt.
There we go, chat.
A vehicle subsystem issue that will take us beyond our launch.
Scrub-a-dub-dub on X.
We are reviewing opportunities for our next launch attempt. So
where though?
Scrub today's NG1 mission to give the team more time to work that issue, and we're reviewing.
Ah, there we go. 1 minute ago. Perfect.
Things that we might need to get done in that period.
Yep, no worries.
When we know when the next opportunity is, of course, we will let everybody know.
Probably 2-day turnaround time.
Sense of what happens next. The launch team is now working to detank and safe the vehicle. From there, we're going to assess, as mentioned, what other things we might want to get done in our downtime, and that is what's going to guide when the next launch opportunity will be. Follow us on social media. That's the way to stay up to date on announcements for that next launch attempt. We do want to thank you for joining us. We can't wait to get right back here for our next launch attempt. Stay tuned. Gradatum Ferociter.
Gradatum Ferociter. All right, chat. Well, there you have it. All of that boiled down to a scrub-a-dub-dub for the evening. So anyways, disappointing, certainly. But yeah, no biggie. No biggie, chat. We will just wait for the recycle and the new date for the launch. Most likely it's going to be like a 48-hour turnaround time. Because they might, honestly, with how long that's been going, they might have to like do some refilling of the pad and stuff like that, some of the resources on the pad and whatnot. But yeah, I hope you guys enjoyed the content. Like I said, I tried to do more of these, and I tried to come with all of my notes so we can have a pretty long and good discussion, fill all the air, and show you as many pictures as I have. But yeah, chat, I hope you guys enjoyed it. So we will be back probably later today, if I can swing that, because Monday is my normal streaming day. So we will probably be getting back into some more Kerbal Space Program as we anxiously await for all of the launches to happen. So yeah, speaking of launches, where are we at with launches now? So we'll wait to hear about Blue Origin. We have a Starlink tomorrow morning. We have a transporter on Tuesday. Oh, we have the Blue Ghost mission on Tuesday, chat. I might be streaming that one. Blue Ghost is being launched on Falcon 9, and Blue Ghost is actually a lunar mission. It's a small lunar lander being developed and operated by Alpha. No, I'm not, sorry, not Alpha, Firefly. Firefly makes the Alpha rocket. Yeah, so Firefly is sending their Blue Ghost Mission 1 to the moon on Tuesday, so I might be streaming that as well. And then we have Starship on Wednesday at 3 p.m. Mountain, so I will hopefully definitely be able to stream that. And then the way it's shaping up, New Glenn might have a 2-day turnaround time and might be launching Wednesday. So we'll see. It's a lot. There's a lot happening this week that I want to cover, but we'll see. Anyways, Chad, so I'm out. Have a wonderful evening, morning, wherever you may be. And so we'll pick this back up, I guess, later today, because technically it is Monday for me. So yes, indeed. Until then, chat, enjoy your Monday.